Hi, and in this series of videos, we will learn all about using the Linux command line. If you really want to learn Linux, you have to understand how to use the command line. It's where the power of Linux really lies. In this course, we won't assume any prior knowledge of the command line. All we're going to assume is that you have access to a Linux system somewhere and you want to learn how to use the command line. What we're going to learn in this course, we'll talk about navigating the directory tree, managing and viewing files, viewing and managing processes, understanding permissions, using wildcards, customizing your shell experience, and we'll even delve into using the VI text editor. We're going to do all of this from the command line. When we're done, you will have a solid foundation in the use of the Linux command line. In this video, we will ask an important first question. Why learn the command line? You might think, hey, haven't GUIs come far enough that we don't need this old-fashioned stuff like the command line anymore? It's true that operating systems and graphical interfaces have come a long way, and this is particularly true in the Linux world because Linux comes from the Unix tradition and is traditionally command line based. What I'm using here in this video is a stock installation of Linux Mint version 17.1. You can see the logo there on my screen. But the things here in the GUI are going to be common to what you'd see in Red Hat or SUSE. This is not a demo of Linux Mint. This is more of just a discussion of what kinds of things are in a modern Linux. There's a menu. In this case, it's down in the lower right-hand corner. And I bring it up and I can see all sorts of categories. So first up under accessories, you can see I have all sorts of things. A font viewer, a document viewer, calculator, a screenshot, and the terminal. That's what we're going to be talking about most during this course. But all sorts of tools and accessories and things like that. Under graphics, the main one to point out here is GIMP. GIMP is a full-featured graphics editor. This has layers and masks and all the drawing and editing tools that you'd expect in one of those kinds of programs. Under Internet, you see we have Firefox web browser. That works just like Firefox works on Mac or on Windows. Firefox is the default browser that happens to come with Mint, but Chrome is also available. And again, Chrome works just like it does on Windows or on a Mac. Under Office, we have a suite of applications called LibreOffice. This has all the things that you would expect in an Office suite. We have Calc, which is a spreadsheet program. Draw is a flowcharting and diagram making thing, kind of like Visio. Impress is a presentation software like PowerPoint. Math is for typesetting mathematical equations, especially because Linux tends to be heavily used in the math and science fields. That's actually a nice feature to have. And Writer, that's your standard word processor. LibreOffice isn't Microsoft Office, and it's not going to be 100% the same features as Microsoft Office. But it is largely compatible with Microsoft Office files, and you can work with people who are using Microsoft Office and probably not run into too many file compatibility issues. Under sound and video, we have some audio players and some video players. We have administration tools and setting preferences and things like that. Pretty much anything you need to do with the system under preferences and administration, setting up the network, setting up the display, adding users, configuring printers, all those kinds of things can all be done from the GUI. There's even a file browser, and I'll open that. The file browser looks like what you'd expect a file browser to be. It has directories, it has your files there. You can double click on files to open them. You can rename files, you can delete files, you can move files. All the things you expect to be able to do with the file browser again on Windows or on a Mac. So we ask the question again. If you can do all of this from the graphical user interface, why would you want or need to learn the command line? And we'll give 3 answers to that. The first answer is you might not need the command line. If what you want to do is use the Office tools, use the image editing, do internet browsing, things like that, you may not ever need to open the command line. That said, the other 2 answers, there are 2 good reasons I can think of for learning the command line. The first is that it's a valuable job skill. If you put on a resume that you know Linux, the employer is going to read that to mean that you are saying you understand the command line. Conversely, if an employer lists Linux as a qualification for the job, that employer almost certainly means knowledge of the command line. I work as a system administrator at a university, and almost all of my work is from the command line. I do very, very little from the GUI. And so that kind of brings us to the second reason, the third answer to the question. The command line is far more powerful and, perhaps surprisingly, often easier than the graphical interface. We're going to do a couple of examples here just to show you a flavor for how that can be. So here in my Documents folder, I have a typical folder. It has some files and it has another folder. Now, let's say I want to move some of the files into that subfolder. I can click on the first one, shift-click on the last one, and move them into that folder. Just drag and drop, exactly like on Windows or on a Mac. Renaming a file is a similar operation. I can right-click on a file, and I can choose Rename, and I can say the new name is new name, and hit Return. That's easy enough. Wasn't very hard. It relates to knowledge that I have from other operating systems. So why would I want to do that from a command line? Well, let's open a terminal window. And don't worry about the specifics of the syntax of what I'm doing here. This is just sort of a demonstration. We'll cover all of this throughout the course. I go down to my Documents folder, and here's my folder. You can see it's the same thing. If I go into a folder and I want to move all those files, here's the command to do that. I want to move those back up to the folder where they started, just like that. I didn't have to type every name. Asterisk is a wildcard. It says everything you find. And ... is a special name for the directory one level up. Here's a look at that directory. There's nothing in it. Let me go back up to this directory. There's a look. All my move me's are now there. With a few characters on one line, I was able to handle all that. And it wouldn't be a whole lot more to do specific kinds of files or to do files in multiple directories and move them all into one place. Very, very quick and efficient way to do things. Now, how about the rename? That's also a simple command. If you were really observant, you may notice the same command to move the files and to rename. Just happens to be that it is the same command that renames a file or moves it, the mv command. And again, don't worry about that syntax. We will cover that in the course. Like I said, these are very quick and simple tasks to want to do. But what if I wanted to rename hundreds of files? What if I wanted to move dozens of files or hundreds of files? It can be not a whole lot more complicated than this. Now think about the graphical version of the rename. If you were renaming hundreds of files, it would not be a pleasant task. So there's a couple of quick examples, and really this is just scratching the surface of the power that's behind the command line. So why learn the command line? It's a good job skill, and it's a lot better way to do a lot of things. In this video, we will cover how to access the command line. Obviously, before we can start to use the command line, we're going to have to access it. In my demonstration, I have Linux Mint, and I'm specifically running something called the Cinnamon graphical user interface. Different versions of Linux have different graphical interfaces, and even within a version, there can be various graphical interfaces. Just keep in mind as we go through this that the specifics of where things might be and even how they look and what they might be called can vary. The general idea is going to be the same if you're using something other than Mint. Specifically in this interface, I have three ways pretty much right in front of me here to access the command line. The first is right here on the menu bar. I have this little icon down here. When I mouse over it, it's called Terminal. If you look at it, it's supposed to look like a computer screen, and it's got a prompt on there to show me that that's where I access the command line. Terminal or something like that. You might see xterm in different systems, but terminal or xterm or something with some kind of a terminal in the name is the program you're looking for. This goes back to the days when a Unix system was a big computer in a room somewhere, and all the people using it were in another room somewhere, and they were at terminals. If you Google DEC VT100, you'll see one of the original terminals that was used with Unix. What we're doing in the graphical interface is a virtual version of that. So they still call it a terminal, even though it's really just a window. And the icon is supposed to harken back to the days of those terminals. The two other places are on my menu. I have a set of icons on the left-hand side, some things that I might want to access, like the system settings and the system administration settings, web browser, how to install packages, software update kind of thing, and the terminal. That's like the big four, if you will, from what Linux Mint programmers thought were the big four of programs that would be used on a system. And the third place is over here under accessories. You can see right there again, I have the same icon and the name terminal. And you can see here, it highlights with a description of what terminal does, and it says use the command line. Wherever you find it, something called terminal or something like that, open it up. You should see something like this. It's going to be a window. It's going to have a prompt. You see I have a blinking cursor there, and the terminal, specifically the command line, is now available and is waiting for me to do something. In this video, we will be discussing Linux shells. What's the difference and why should I care? So far, we've been talking about the Linux command line and we haven't really defined it. We've just sort of assumed that there's this understanding of what does the Linux command line mean. Well, it turns out there are actually multiple programs available in Linux which give you access to a command line. The general category that these programs can be grouped into would be called a shell. The job of a shell is to give you a command line and enable you to run Linux commands. And it turns out that these shells are not necessarily compatible with one another, so it really does matter which one you use. And so in order to discuss the shells, we need to define what these different shells are, which one we're going to use, and why we're going to use it, and why it matters that we're all using the same one as we go through this course. So to do that, we're going to back up. We're going to do a little history lesson. I promise not to make it a long or boring history lesson. Unix was developed at the company AT&T in the 1970s. And at first, there was just one shell. It wasn't ambiguous to say the shell or the command line. That shell was called the Bourne shell. The name of the command is sh for shell. It's called the Bourne shell because it was written by a man at AT&T named Stephen Bourne. And for a while, that was the shell. Everybody used the same shell. Well, as time went on, some other programs were developed to do the same job, but with some enhanced functionality. One of those is called the Korn shell. The command for it is ksh. It was written by a man named David Korn. He was also at AT&T. It was written in the 1980s, and the Korn shell introduced a lot of extra features while keeping a very similar syntax to the Bourne shell. Now, there was another one that came out of UC Berkeley, a guy named Bill Joy. He later went on to found Sun Microsystems. Bill Joy created a shell called the C shell. Now, the goal of the C shell, when you get into the actual syntax of the Bourne shell, it is a programming language. It's actually a full-featured programming language, but it doesn't look anything like C. And Unix and Linux are written in C. The idea was, let's create a shell that looks and feels more like the C programming language, and that was the goal of the C shell. The C shell uses a radically different syntax and actually has some things that don't work as well, don't function as well in the C shell. And over time, the C shell has kind of fallen into disfavor, and you won't see it used all that much. Now, in the open source world, there is a shell that is the most common shell, and it's a variant of the Bourne shell and the Korn shell, and it's called the Born Again shell. Obviously a pun on the name Bourne shell. This is a newer Born Again version of the Bourne shell. The syntax of bash is usually how it's pronounced because Born Again shell is a mouthful. Bash is the name of the command, and bash is what the shell is usually called. The syntax is a lot like the Bourne shell and the Korn shell. It does have a lot of extra features. So it's the Korn shell is an enhancement of the Bourne shell, and bash is an enhancement of the Korn shell as a way to think of it. And bash is what we'll be using in this course. And as a side note, bash is also the default shell in Mac OS X. So if you open a terminal on a Mac, you're also using bash. Now here's why it matters. Bourne shell, Korn shell, and bash all have a similar and compatible syntax, although some different features and different enhancements. But the C shell and the TC shell, which is an update of the C shell, both have a very incompatible syntax. So you definitely don't want to be using one of those. There's going to be some significant differences with this course. For this course, it wouldn't make a huge difference if you were using certainly the Korn shell, maybe even the Bourne shell. But for this course, it's not going to be that big a deal. Just make sure you're using bash and you will be fine. And if you are using a Linux system, any modern Linux system, it is almost guaranteed that you are using bash. But let's make sure. So how do we make sure? Let's jump over to our terminal and take a look. So here we are in our Linux environment. We've opened a terminal window and we are now running a shell. How do I know we're running a shell? Because I see a prompt and the cursor is sitting there waiting for me to do something. What shell am I running? I can't really tell. Nothing about this particularly says what shell I'm running. But there are a few different ways that we can find out what shell we're using. The first and probably simplest is to use the command ps. PS command shows us processes. PS is for process. And it tells me the processes that I'm running in this window, and I'm running two at the time that the PS is going. I'm running a PS, and I'm running bash. There's my indication. Bash is the shell that I'm using. The second way that we can check our shell, I can echo $shell. Now, some important things about typing commands on the command line. Spaces matter, capitalization matters, and there are special characters. And in this case, the $sign is a special character. So the echo must be in lowercase. The word shell must be in uppercase. There must be a space between echo and $shell, and no space between the $sign and the shell. All that has to be the case for this to work. But if I do that, $shell is actually a variable that tells me what my shell is. And this gives me the full name of my shell, the command bash, and it lives in the bin directory is what this is saying to me. A second way to show that my shell is indeed bash. If you are using bash, great, you're set for the rest of this course. If for any reason you are using a different shell when you do these checks, no problem, no worries. All you have to do is type the command bash, and I have actually now started another bash shell. So I'm now running two bash shells in this. It's getting a little hard to see. There's nothing visual that tells me that. But if you were running a different shell, you can just type bash, hit return, and then you'll be running bash. In this video, we will be looking at basic shell interaction. Now, the shell's fundamental function, if you will, is to provide an interactive session where you type commands and then things happen. The shell, bash in this case, the case we're using in this class, gives us a prompt, and it is now sitting here. What you see on my screen is a prompt, and it's waiting for me to do something. So, for example, I can type date and hit return, and it responds back with the date and time in my time zone. Every command ends with a carriage return. The shell works one line at a time. When it gets a line of input, in this case when I hit carriage return, the shell then looks at that line and decides what needs to happen and then takes that action. Commands maybe don't have any arguments to them, but they can also have arguments. The date command can work either way. So for instance, if I say date plus %Y, that tells the date command, tell me the current 4-digit year. So there are a variety of options to the date command. Date plus, the plus is telling it that I want it to use a particular format, and then %sign and a letter. These are different formats in the date. Here is the day, month, and year in my local representation, which, since I'm in the United States, is month, day, and year, 2-digit year. There's just a lot of different options to the date command. Side note with the date command, this is shown with %s. This is the actual internal representation that Linux uses for the current date and time. What Linux uses is the number of seconds since January 1st, 1970. If you have always wanted to know how many seconds have there been since January 1st, 1970, now you know. There are a number of other options with the date command, and this is not a video about the date command and all the options with it. What we're really showing is different things can be typed on the command line, different things happen as a result of those, and a single command can be rather flexible in what it does. So one command with different arguments can give me very different results. But even so, it's typical for a command in Linux to do only one thing. This is sort of a Unix and Linux philosophy, is that a single command should do a single thing. And then we can combine multiple commands together if we want to do something more complex, sort of like building blocks. So, for example, the date command deals with date and time. And in fact, with the right privileges and the right options, it can set the date and time on the computer. The date command does not deal with file permissions and file ownership. In fact, those are actually two different commands in Linux, and we'll see those later. File ownership is one command, and file permissions is controlled by another command. So that's the basic idea of the command line. We type commands, we get a result back. In this video, we will be talking about the Linux directory structure, what it is, and how to get around in it. The Linux directory structure is a tree. It starts at a root, and in fact, that directory is called the root directory, and then everything branches out from there. Any particular directory, including the root directory, can contain files or other directories. That's going to be very much like you're used to in other operating systems. So let's take a look at something. This is a very small, very selective portion of the Linux directory structure, directories and files in Linux. And so you can see at the top we have a directory. That is a directory name, that slash. That is the name of the root directory. It's called the root directory. We don't ever call it slash, but it is spelled slash. So that's just something to get used to. That directory happens to contain several directories. We have a bin directory that's for binary files. We have an etc directory that's usually configuration files, etc. But it's pronounced etc. It's spelled etc, but it's pronounced etc. We have a home directory. That's where home directories go. TMP for temp. USR for user. That's things that are not related to the system usually. It's just another directory. You can see there's a bin directory in there. There's a local and a bin. So there's multiple places where binaries can be. And there's a var directory that contains generally volatile type files, log files, temporary files, things like that. So that's just a rough, very selective look at the directory. So I can have things that are in the root directory slash, but I can also have things, for instance, in my documents folder. From the top, there's a home directory, there's a Jeff directory, and there's a documents directory. So that's my documents directory in my home directory. So if I wanted to spell out my home directory, it is /home/jeff/documents. Now, you notice we didn't separately specify the root directory. Slash is the separator between directories, and it's also the root directory. So we don't separately specify root, we just say /home/jeff/documents. Now, if the path to a file or directory starts with a slash like this one does, that's called an absolute path. And all that means is the path begins at the root directory. We know that it begins at the root directory because the name specifying it begins with a slash. We can also specify what's called a relative directory. If I were in the home directory and wanted to specify the same thing, my documents directory, I could say Jeff/documents. Now, when a path like this begins without a slash, it's called a relative path. And what that means is it is relative to the current directory that we're in. So how do you know what directory you're in? Well, there's two basic ways. The first is the directory is actually being shown in my prompt. Now, that's not 100% reliable, and we'll talk about why it says tilde in a little bit, but it's showing me the current directory I'm in. The reason I say it's not 100% reliable is because what shows in the prompt is actually configurable. It's actually a configuration item. You can change what the prompt says. The default is usually to include the path in the prompt, but there's no guarantee of that. So what's a guaranteed way of finding out what directory I'm in? There's a command, pwd, for print the working directory, and it says I am in /home/jeff, which happens to be my home directory. You will find as you get familiar with Linux commands that a lot of them tend to be kind of short, like really short. You might even think they're a little terse. Sometimes it seems like they're allergic to vowels in Linux commands. It's just a way of shortening everything. It's accustomed to be somewhat terse in the command name. And I think the idea is just if you're going to be typing these things, don't type any more than you actually need to type. So you will get used to it, even if it seems a little odd initially. So here it shows that I'm in /home/jeff. If I want to go to another directory, the command is cd, and then I give the directory name. So if I want to go up to the home directory, I cd to /home, and there I am. And now you see my prompt changed. My prompt changed to tell me that I'm in /home. And I can do a pwd, and that shows me that I'm in /home. Using absolute paths, I can go directly to any place in the entire tree. I can go directly to user local bin if I want to. I can jump straight there. You may notice I didn't say /user/local/bin. I said user local bin. That's just another shorthand that people tend to use. People who are familiar with Linux, user local bin happens to be a very famous directory. It's a very commonly used directory. And so user local bin is a lot easier to say than /user/local/bin. Less common directories, you will hear the slashes said. I cannot give you a specific rule about when slashes are pronounced and when they aren't. It's just one of those things that you'll pick up as you hang around people in the Linux community. If I want to go back to my home directory, there are actually several ways I can do that. The first is what we would guess. I can type the full path to my home directory. And there I am. That fact that there's a tilde in the prompt right now, we made mention of it earlier, that's actually a clue. And I'm going to show you what it's a clue to. Let's go back to user local bin, but this time we're going to do it using relative paths. So I'm going to go to the root directory, and then I'm going to go to user. Notice I used a relative path there. A relative path can have multiple components in it. I can cd to local/bin. And you notice I'm exactly where I got with the absolute path. As long as I'm using a correct relative path, it's going to get me to the same place. It's the same thing. It's just whether I'm starting at the very top or I'm specifying a subset of that path. If I'm in a part of that path, I can still use the absolute path. There's no harm in always using the absolute path to get somewhere. So now I'm here, and we've had this little clue. When I was in the home directory, it didn't say my directory was /home/Jeff in the prompt. It said it was tilde. So what happens if I type cd tilde? That's the tilde character right next to the 1 on a US keyboard anyway, and you type it with a shift. There I am. What directory am I in? I'm in /home/Jeff. So it turns out that tilde is a shorthand for my home directory. And so tilde will have a different meaning for me than it will for you or your friend or anything else. Every individual, tilde has a different meaning because it's relative to the user. It is that user's home directory. So let's go back to user local bin because there's an even shorter way to get to my home directory. So did you notice what I did there? If I give no arguments to the cd command, that means the default is go to your home directory. So that can be pretty handy. If you're off doing something else in another directory, maybe you're working on something in user local bin, for example, and you want to get back to your own home directory, just type cd and you're back. Now there are two more special directory names that we need to talk about here. The first is ... two periods right next to each other. What ... means is the directory one level up. Specifically, that directory is called the parent directory. Every directory except the root directory has a parent directory, and that parent directory can always be referred to as ... So if I'm in user local bin, the parent directory is user local. If I'm in /home/Jeff, the parent directory is /home. But ... will always take me to whatever that directory is. ... means up one level. The other name we want to call out here is very similar. It's dot. Now, if I do a cd dot, what happened? Dot is a name that always means this directory, the current directory. So what use is that? Well, with the cd command, it's not terribly useful. I would like to go nowhere, please, isn't a very useful command. But sometimes you want to specify a file or you need to specify a file very explicitly. You can specify it's in the current directory by saying ./Jeff. This maybe doesn't make much sense in the cd command, but we can do that. We can say start at the current directory, then go to Jeff. And again, pwd, just to prove I have made it home in this little tour of our Linux file system. So just remember, the cd command moves you around. Remember how to spell paths, the difference between an absolute and relative paths, and these three special names, tilde, ... and dot. And before you know it, you will easily be able to move around in the Linux directory structure. In this video, we will discuss one of the most important Linux commands there is. It's one you'll use a lot. It's the ls command. ls produces a file listing. So if I just type ls, I get a listing of the files in my home directory. It's just that. It's a listing of all the files and directories in my home directory. This is not all the contents of my home directory. There's actually some things that ls isn't showing me. I can add an argument or a flag, the terms are both used, to the ls command. The standard way of specifying an argument to a Linux command is a minus sign, a hyphen. Usually it's pronounced minus. This command that I've just typed is ls minus a. And the A in this case stands for all. And it says, show me all the files, not just the ones you want to show me by default. You see, I get a much bigger listing. You notice all the new files, if you take a look at this, everything that showed up new is preceded by a period. We call that period a dot. We're used to that in domain names and URLs and that kind of thing. Same nomenclature is used. We have dot bash underscore history, dot bash underscore logout, dot cache, etc. It's just a convention, a standard way that Linux does things. A lot of configuration files, preferences files, that kind of thing. Things that you don't normally need to see. It's nice if they're just sort of out of the way. Those files begin with a dot, and ls and also the GUI file browsers won't show those to you by default. They're sometimes referred to as hidden files or dot files, but with ls-a, we can say, show us all those files. Also, we see in here are two special directory names we talked about. We have dot and dot dot. Just as a reminder, dot is a name that means this directory, the directory that we're looking at. And dot dot means the parent directory, the directory one level up in the tree. By default, ls lists things alphabetically. We start from A and we go to Z. I can reverse that notion by adding a flag minus R for reverse. If I do that, I go from Z to A. Pretty straightforward. I can also list by time. Now you see here, I created a file called new file. That file was created today. So it comes first. It's from newest to oldest. The oldest thing here is my desktop. For a directory, the definition of the time it was modified is the last time something was added, removed, or renamed in the directory. New file is a file that was added, like I said, just today, so that it would be new. And desktop happens to be the least recently modified thing in my home directory. Now I can combine these arguments. If I want to go instead of from newest to oldest to newest, I can combine the two flags. And generally speaking, when we combine flags, we don't need a separate minus sign for each one. We can just add them all behind one minus sign. So I can say ls minus tr. Now I've gone from oldest to newest on my listing. You don't need to combine them. I can separate them and do both with the minus sign, and exactly the same thing happens. Why might you want to mess with the sorting order? It doesn't make a lot of sense in a small directory like this, but in a very large directory, it can make a lot of difference. Maybe I'm interested in the things at one end of the list or the other, especially if I'm sorting by time. Let's take a look at a big directory. This is one of the system directories. It contains a lot of programs in it. User bin, it's one of those well-known directories, so we often don't say slash, but the user bin directory. There's a whole lot of things in here. In fact, you can see I pretty much see X, Y, and Z at the end of the list. It's a two-column format, so I'm getting the M's as well. The N's and the O's and the P's are off my list, and of course the ABCs are off my list. Maybe I'm looking for an A. I can do an ls-r of user bin. Now my A's come first. I'm still at the M's on the other end of the list, because that's right about in the middle. The A's are coming now at the end of the list, but we have a few other guys that are coming after the A's, so normally they would sort before the A's. You can see that numbers and, in fact, punctuation marks, most of the punctuation characters, there may be some exceptions, sort before the alphabet and the numbers. The numbers come first, but even before that are punctuation marks. That little square bracket is actually a command. It's an unusual command, but it is actually a command. So if we add A to the mix, when looking at our directory, we see our friends dot and dot dot. Again, a reminder, they are there in every directory. ls by default shows us the current directory. Also, we can specify any other directory. And just like we did with the cd command, we can specify that with an absolute path or with a relative path. We will come back to ls in another one of these videos, but for now, this does conclude our basic introduction to the ls command. In this video, we're going to briefly discuss how the shell understands what you're saying when you type. And specifically, we'll be looking at what happens when you hit return. It's not quite as simple as it might first appear, and understanding what happens, what the shell actually does, is helpful, especially as you get to doing more complex things in the shell. First up, the shell works on your input line by line. At the end of each line, when you hit return, the shell takes a look at whatever you put on that line, and it interprets that in some ways we'll look at, and then it takes action. And the action is dependent on the contents of the line, and in fact, what actually happens can be different from what you typed. And that's a good thing, by the way. We'll look into that. We're going to take a look at some examples, and we'll use the cd command that we've seen before. And just as a refresher, the cd command without any arguments goes to your home directory. I was already there, so nothing happens. When I hit return, again, we'll do cd. I've typed a line, nothing is happening yet. It's only when I hit return that the shell then takes action. And the first action it has to do is figure out what command it is I'm trying to run. Let's say I didn't know the name of cd and I thought maybe it was goto. And so I want to type the command goto. So for now, I've typed goto, nothing has happened, nothing's wrong. But as soon as I hit return, you notice there was a little pause there. The shell went kind of like, I don't know what this is. It was trying to find something. It couldn't find anything. Linux actually is helping me out by trying to figure out if there's any commands I could install that might be what I'm looking for. The end result is I get goto command not found. There is no command goto. So the first thing the shell has to know, is this a command? Is it a valid command? Is there something I can do with what you've typed? Now, what's the definition of the command? Everything up to the first whitespace, so a tab could count to, is considered by the shell to be the name of the command. How does it find that command? Well, there's actually a setting, if you will. It's called an environment variable. There's a setting, and I can show you mine, called the path. And it's a list of directories. And so what the shell does is it basically looks in each one of these directories. So when I said goto, it says, is there a goto in user local sbin? No, there's not. Is there a goto in user local bin? No, there is not. Is there a goto in user sbin? No, there is not. Now it does that a little more efficiently, but that's effectively what it does. There's a command called type that will show me what command is being executed when I do something. So for instance, with the cd command, I can say type cd and it'll tell me exactly where are you finding that command cd. Now, it didn't find it in any of those directories. There's actually some commands that are built into the shell, and cd is one of them. Cd happens to be a command that the shell does for itself. It doesn't need to go execute some other program. If we take a look at another program, one called cat, that just takes the contents of a file and puts them out on the screen, that actually is a program sitting out on the disk. It's in the directory /bin. So cat is /bin/cat. Whether a command is built in or it's a program out in a directory somewhere, the input line is parsed the same way. So first, we have to know what command is being done and how to execute that command. Either we're going to run a program or it's going to be an internal process. But then we find the command and we look at the rest of the line and see what's on it. Now, if I just type cd, all that happens is I call the command cd with no arguments. Cd with no arguments means go to the home directory. If I type cd tilde, that also means go to the home directory because tilde is a special name for my home directory. Now, what you might think is happening is that the cd command is given an argument of tilde. That's actually not what happened. So if you remember at the start of this, we said that the shell interprets the line before calling the command. And that's exactly what happens here. There's a special way that we can see what's going on under the hood. We can type set -x, and that basically sets a debug level on the shell. And what the shell is going to do is it's going to show me everything that it's doing before it does it. So let's do that cd tilde. So the shell puts out, okay, here's what I'm going to do. I'm going to cd to /home/jeff. And that's actually the command that gets executed because the shell turns the tilde into /home/jeff before it calls the cd command. That's what we meant by the shell will interpret the line. There's all kinds of special things the shell can do. Changing tilde into the path to your home directory is one of them. But the shell does that before it calls the command that you have typed. Essentially what the shell did when I hit return, it said, okay, let's take a look at this line. We have a CD, we have a space, we have a tilde. Is any of this special? As a matter of fact, the tilde is. Tilde means his home directory. I will look up what his home directory is. His home directory is /home/Jeff. Therefore, I will call cd space /home/Jeff. And that's exactly what it put on this output with the debug on. So if we go back to when I looked at the path, I said echo $path. Let's take a look at that with the debug on now. What I really said was echo this long value that was the path. So variables are another thing. That's what the $path is. It's a variable. And variables are another thing that the shell interprets. The contents of the variable are put on the command line, and then the command line is executed. And that's another way we can go to the home directory. There is a variable for your home directory. So when I do that, I get the same result as the tilde. $home is the same as tilde, and it's the path to my home directory. Again, the important thing to remember is that every line we type to the shell will be interpreted by the shell. Sometimes it just turns into a literal string of characters. If I say cd/bin, the command that gets executed is cd/bin. Then if I say cd tilde, the command that gets executed is cd/home/Jeff. Every time we hit return, the shell is taking a look at it, seeing if there's anything that needs to be interpreted, interprets whatever it needs to be interpreted, and then calls the command that we have called. The more complex things we do in the shell, this is going to become very important to understand. So it's an important concept to grasp. This is a great convenience, but it can also cause problems when things are unexpected and something happens that you didn't think was going to happen, both for good and for bad. When you want the shell to understand things a certain way, or when you're surprised by the way the shell does something. It's important to know that the shell interprets things before passing them to the command. In this video, we'll be looking at some tools for dealing with files. Specifically, we'll be looking at the commands cat, head, tail, and less. First, let's talk about cat. Cat has one basic function that it does, and that is to display the contents of files. So if we do an ls, I'm in a directory here that I made just to have these two files to make it sort of clean visually. These two files, hamlet.txt and macbeth.txt, are available in your working files directory, so you can follow along. And these are simply the text of two famous Shakespeare soliloquies. We have Hamlet's to be or not to be speech and Macbeth's hallucination about the dagger. And this is just to give us some text to work with as we do these commands. So let's start with the cat command. Cat can take no arguments or take an argument. In this case, I'm going to give it the argument of hamlet.txt. The arguments to the cat command can be one or more files, and we'll see both of those cases. Cat hamlet.txt. And you can see some text pops up. It goes by very quickly because the computer's pretty fast at displaying the text. What happened here? I just displayed the entire contents of the file. The file is long enough that it exceeds the size of my terminal window. Now I can come over here with my pointer and I can scroll back and I can see the full text of the file. But we've just stepped out of the command line here. We're not using the command line anymore to do that. We're using the GUI to look back in what happened on the command line. So we really don't want to do that. We can do something a little better in a little bit. But first, the basic function of cat, it takes the text in the file and outputs it to the screen. I can give it both files, Hamlet and Macbeth. And if I do that, I get, looks like maybe the tail end of Macbeth's soliloquy. And again, if I scroll back, I can see that we started with Hamlet and then we went to Macbeth. And you'll also see right in here, there's no break between the two files. It just ended one and started the other. And that actually gets to why this command is called cat. Cat is short for catenate or concatenate. They're synonyms. Cat takes whatever you tell it to use and concatenates it all and displays the result. It may seem weird to use the word cat. Cat this file means to display this file. You'll get used to that usage, but it actually comes from concatenate or catenate. Cat kind of shows us everything, and it may or may not be useful to us. Let's look at a tool that can show us a little less. Maybe we suspect that Hamlet is that speech, because we've worked with it before or something like that, but we're not entirely sure. We can use the command head, and if we use that, by default, head shows us the first 10 lines of a file. And we can see, yes, indeed, that is the to be or not to be speech. We can change with an argument how many lines we're going to show. So for instance, we can say, give me 5 lines. And the argument for the number of lines is simply a minus sign and the number of lines. We can do head -1 and show just the first line. We can do any number of lines. You get the idea of how that goes. So a question you might ask at this point, what happens if I say more lines than are in the file? What if I say, give me 1,500 lines of Hamlet? Hamlet itself is more than 1,500 lines, but this speech isn't. We do that, and we just get the whole file. So it's no big deal if you specify more lines than there really are. Now, a cool thing that head does, if I say head -5 and I give it both files. By the way, I'm just typing a tab here to complete that. This is a feature of Bash. If you type part of a name and hit tab, it will attempt to complete it. If it's unique, it will just complete the name for you. If it's not, it'll show you the various choices. So that's just a handy little shorthand to prevent some typing. If I do a head on both of these files, what I get is kind of a nice little format. It tells me, okay, here's the first 5 lines of Hamlet.txt, and here's the first 5 lines of Macbeth.txt. You can do that for up to as many files as you possibly wanted to. The similar command to head, not too surprisingly, called tail. So if I take the tail of Hamlet, just like with head, I see the last 10 lines of the file. We'll just do a blank there to visually separate that. If I do a tail -1, I get the very last line of that speech, etc. It is documented in the documentation I looked at that this should work, just like it did with the other. But it actually doesn't work in this version of tail. But we can do a variant of this and tell it explicitly that we want 5 lines, and then we get an output similar to the head output, but doing the last 5 lines from each file. So we can put the whole file out, we can look at just the beginning of the file, we can look at just the end of the file. What if we actually wanted to read the file? So again, if I do cat hamlet.txt, I can't really read that from the command line. I can scroll back in the terminal window, but like we said, that's cheating. That's using the GUI. So what if I actually want to read it? Well, there's a command that can do that as well. There's a command called less, and here's what less does. It starts showing me the file, and it stops at the end of a screen. And it's actually giving me a prompt here. So I have the first one screen full of text. And I can hit space to go forward a screen. I can hit B to go back. I can do the return character to go down one line. There's a bunch of other things I can do in there, but those are sort of the main things. If you do want to see all the other things that less can do, you can type H for help, and you will see a very large list of commands that you can do in less. Don't worry about those to start with. Space to advance, B to go back, return if you want to go by one line. That's pretty much enough to get you to move around. Now when I get to the end, I'm hitting space now, and nothing's happening. So how do I get out of the file? Well, that's the one extra thing you need to know. Q for quit gets you out of the file. Like with head and tail, I can specify more than one file with my less. So if I do Hamlet, here I have Hamlet. Same thing, I get to the end, I'm pushing space, nothing's happening. I can do Q, and if I do Q, I just quit right out. That's not terribly helpful to me because I didn't see the next file. To show the next file, I have to type a colon and an N, and then I get to the next file. And then finally, Q to leave. In this video, we are going to look at some commands that can tell you a little bit about your system. The first command we'll look at is df. df shows you all the disk space you have allocated and how much you're using. So let's take a look at that. There's a number of things listed, and all these ones that are none, those are some special things you don't need to worry about. Kind of the same with the tempfs. So really that first one, the one that starts with /dev/something, those are the ones you're going to need to look at. You may have just one big file system, or you may have a number. That's going to depend on your system. What we see here is, in the case of that first line, how big is the disk, how much I'm using, and how much do I have available. It's 21% full, and it's mounted at my root file system. That's all useful information, but these numbers don't really tell me a whole lot. It says they're in 1K blocks. By default, DF shows everything in blocks, and your block size can be different. It can be half a K, it could be 1K. Mine happens to be 1K. Those are all in K, but like the available space, it's not even got commas in it. It's like 18 million K or something like that. But there's a better way. If we add an argument -h, the H is for human or human friendly or human readable, and it says show the numbers in a way that makes good sense for humans. Now this is much better. My disk is 24 gigabytes. I've used 4.5 gigabytes, and I still have 18 gigabytes available. Very easy to understand in that sense. So that's the df command. Now let's take a look at the uptime command. Uptime does one basic job. It shows me the uptime of my system. First we have the time, then how long it's been up. My system's been up for 3 hours and 15 minutes. There are 2 users logged in, and that's basically my GUI login and my terminal login. And then the load average is 3 numbers. It's a 1-minute average, a 5-minute average, and a 15-minute average of really how busy the system is. Essentially what that number is saying is at any point in time, how many processes are trying to run, trying to actually do something on the CPU. They're not waiting on anything. They're not sitting idle. So for example, right now, most of my system is idle because I'm just sitting here talking. There's really nothing going on. And that's why those numbers are so low. And that's the kind of thing you're going to see on a not busy system. If the system is busier, you will definitely see some more things going on. And just kind of as a rule of thumb, if you exceed 1 per CPU, in theory, if you have 4 cores or 4 CPUs on your system, you could have 4 things running on CPU at the same time, and it's not going to be that big a deal because you have enough CPU for that. So that's kind of the rule of thumb. If you're exceeding 1 process per CPU on average, then that means your system is getting very bogged down. Or if you see numbers like this, it means your system's just sitting around doing nothing, waiting for you to do something. The next command we're going to look at is a very simple one called hostname. And hostname shows me my hostname. This is a virtual machine, and I named it Linux just so that it would have a name for doing these videos. It's not a very exciting name. My Linux box is called Linux. It just shows you the hostname. Could be useful at times. Another useful command is the uname command. Now the uname also tells me that it's Linux, but now it's telling me what's the operating system you're running. What's the name of the Unix? That's really what uname is saying. It tells us that it's Linux, but it doesn't really tell us anything more than that. If we give it an argument of -a, the -a in this case is tell me everything. Tell me all the information that you're going to tell me. If we just read this from right to left, we have a Linux box. Its name is Linux. We have the version of the kernel that it's running. We have some information that it's a 64-bit Ubuntu system. Linux Mint is built upon Ubuntu Linux. It's doing multiprocessing. We have the date and time that the kernel was built, and then some indications that it's 64-bit and it's running the GNU Linux system. Uname -a, another source of some useful information. Just a few things to give you some basic information about your system and what it's doing, how much disk space you're using, how busy is it, that kind of a thing. The TTY again. The stat is the current status of the process. Ones you'll commonly see are S for sleeping, and when we did the big one, you noticed most processes are sleeping most of the time. R means the process is running, so the PS process was running at the time the PS process was running. Again, we have a start time, we have a total amount of CPU time that they've taken, and then what the command was. So that's the PS command. Like I said, there are a lot more options. You could spend literally hours just learning about the PS command. But this is enough to just show you what's going on, get a quick look at what's going on in your system. Another real handy way to get a look at what's going on in your system is with a command called top. And that one is the whole word. We get to use the whole word for our command for once with no arguments. And what this shows me is it's a constantly updating display. It's not just a list that goes out. It's a display in my current screen size that is constantly updating, and it's a very handy way to watch what's happening as it's happening. There are a lot of options within top as well. You can do H to see a lot of them. You can just see, whoa, there's a lot of things here you can do. Don't worry too much about that. The default view is pretty much going to be useful to you most of the time. We can see here in top, we've got some things going on. In this video, we will look at several commands that deal with processes. Cinnamon is the GUI process that's running. But you still see, if you look up here on the top, I have the uptime information, the same information that we saw in uptime earlier. I see the total number of processes, how much is going on, how much different kinds of CPU time are being used, and you see that the ID is idle, and some information about memory. Top is really handy. You can see the thing that's... In this video, we will take a look at an example of using these commands we've talked about to deal with processes, and we'll also look at the kill command. We're going to do something interesting here just to give us something more to look at because the system is mostly idle. I have a script called cpuhog.sh, and this is available in your working files directory. When you copy it to your system, you might see something like this when you try to run it. We should put the / in front of it because the current directory may or may not be in your path, so it's easier to just put the /. But you try to run it. If you get permission denied, all you need to type is chmod +x cpuhog.sh. We will cover in another video what that means and what we actually just did there. We're not quite there yet. For now, you can just type that and that should make the script work. So if I type cpuhog.sh, this process goes away and starts doing something and then immediately comes back. In fact, what it's doing is it's just adding 1 and 3 in an infinite loop. So it's just going along and basically uselessly doing an addition, doing nothing with the result. It's just a script, so we can actually take a look at the script. And there you go. It's a loop. It is doing the addition of 1 plus 3. The while colon basically makes it an infinite loop. And it puts itself into the background, which basically means it's running without us having to deal with it. So now if I do top, you'll see my CPU hog is taking up CPU. It's hogging the CPU. You'll also see that my load average on the top line is climbing up. If we were to sit here and wait long enough for that, we would get to a load average of about 2. Let me start another CPU hog. Actually, let's make it 3. Let's just go for it. Starting up 3 CPU hogs. We'll go back to top. So now you see, if you look at my display, my idle time on that third line is now 0. There is no idle time happening on this system. I am completely using up the CPU. My load average is now over 1. So things are just starting to bog down. Eventually, all 3 of my load averages, the one that's up 1.7 now, if I waited long enough, the 15-minute average is obviously going to take longer to get there. These should all end up being at around 3 if we go long enough. We're going to quit again out of the top, and you'll notice I don't have any indication whatsoever that I have these processes going, that all my CPU is being used up. This is where some of those commands are useful. If I feel like things are getting slow, I could do uptime. I could see my load average. Oh my goodness, something is wrong. What is sitting here running and using up CPU now? I see that load average and that tells me that things are busy. I can do top and I can see what is it that's making it busy. Oh, it's this CPU hog. So now what can I do with it? Well, we have a command for just this situation and it's called kill. So if I just type kill, I get an error message that tells me you need to give me some more information. And it's a very terse error message. Generally, the convention is things that are in square brackets are optional. Things that aren't in square brackets are required. So you see I have a required of a PID. That's the same PID we saw in the PS output and that we see in the first column in top. So I need to know the process ID, the PID of the process I want to kill. So if I do a PS, I can see these guys are in here. And I can see that the first one is process ID 6624. So I can say kill 6624. Now if I do PS again, you see that one went away. I have killed that process. So let's just do that with the remaining 2. 7346 and kill 10883. Then if I do a PS, do an uptime, things are coming down. Put a top there for a second, and we can just watch. The load average should start coming down. You see our 5-minute average, our 1-minute average is starting to come down now. Our 5-minute average, the second number, had gone up a little bit. It's going to start coming down a little bit. It moves a little less quickly. And the 15, of course, moves the least quickly of them all. Something you may have noticed about my kill commands, I didn't get any interactive feedback whatsoever. Let's start up a CPU hog again. If I do a PS, I type kill 5507 and I hit return. Nothing happens. Nothing tells me that it's killing the process. Nothing tells me that it did find a process with that ID. Nothing tells me really anything. And this is a general tendency in Linux. Linux assumes if you typed it, you knew what you were doing. If you typed kill this number, you meant kill this number. So it's not going to sit there and annoy you and ask, now did you really mean you wanted to kill this? No, you typed it, you meant to kill this process. So Linux goes ahead and does it. It's a little bit of a misnomer to say that kill kills processes, because that's not actually what happens. Actually, what it does is it sends a message to a process. And the default message of the kill command is the message, you need to quit now. Most processes do behave and they do that, and the mechanics of what's actually happening and what those messages mean and how processes work, that's more of a Linux internals kind of thing and definitely beyond the scope of this video and this course. But there is one situation that we need to cover, and it's important to know that when you kill a process, it doesn't really die. It gets told to quit. If for some reason the process doesn't listen to that instruction or it can't listen to that instruction, then the process is not going to die when you send it a kill. There's two fairly common situations that cause that. The first is if a process is waiting for something, usually waiting for some I/O, and if that I/O isn't happening, you're waiting for something to come in from the network and the remote site you're talking to isn't communicating, and so the process is sitting there, it's waiting for the input, and it's not getting the input. While it's waiting for the input, it's not doing anything else, and so it also cannot respond to the instruction to quit. That happens sometimes. The second thing that can happen is called a zombie process. Now, you got to love that name, right? A zombie process. That is actually what they are called, is zombie processes. In fact, go back to top. When we did top, if we look on that second line, it tells me there are 132 total processes. 2 are running, 132 are sleeping, 0 are stopped, and 0 are zombie. It's an official thing. There are real zombies in Linux. So I have a program here. This one's not in your files. This is just a little program I have here for demonstration. What this guy does is creates a zombie process, just so we can see what one looks like. If I go back to top, I now have one zombie process. What's a zombie process look like in PS? It's this one called zombie, and it has this little defunct by it. The reason it's called a zombie process, and it's actually a very good name, a zombie process is dead, but a remnant of it has stuck around and continues to live on. So it's called a zombie. It's dead, and in fact, you cannot kill a zombie process. Why can't you kill it? Because it's already dead. 200958. I can do that. I can do PS again. I have not affected the process whatsoever. By definition, what a zombie process is, when a process in Linux ends, it always has that parent process that we looked at in PS, and there's a little bit of cleanup the parent process has to do. So if the parent process isn't doing that cleanup, that's what gives you a zombie process. And that's essentially all that little program I ran does. It creates a process, it creates a child process, and then the parent process ignores the child. So we cannot kill the child. The child exits and finishes, but the parent is not paying any attention to that, and so we create a zombie. So the fix for a zombie is to figure out what the parent is. In this case, we know. And if you kill the parent of a zombie process, 20957, if you kill that, now I get told that my zombie is done. And if I do a PS, no more zombies. So that's just a little thing to keep in mind. Because kill sends a message to a process, it does not actually kill a process. There are a couple of situations where a process can't be killed. In this video, we will take a look at something called background processes. We'll talk about how to run things in the background, why you would want to run things in the background, and how to manage them once they are in the background. Now I have a script here. You can find a copy in your working files directory. It's just called longscript.sh. All it does is it takes 20 seconds to run. Now what you can see here, while it's running, I don't have access to my prompt. I can hit return, but nothing really happens because this process has tied up my shell, if you will. It's what's running. It's called running in the foreground. So you can see my script finishes, it says all done, and all those returns that I had typed actually queued up and ran once the script was done. I can prove that is what's happening. I'll run a pwd command and I'll run a date command. You can see nothing is happening. It's running my script. It's out there for 20 seconds. Now 20 seconds isn't a terribly long time, but it's long enough for us to illustrate with. There's my pwd and my date command actually being executed. That input that I had typed was sitting there waiting for the shell when it came back to my prompt. Instead of this little simple script that takes 20 seconds, imagine you had a process that took hours to run. You don't necessarily want to tie up your shell for that entire time. There's a few ways you could deal with this. One, you could just open another terminal window, let that terminal window that you started that process in be dedicated to that process. That's certainly a valid way to do it. You could just wait. If you don't need to run anything else, you could just walk away from the computer, go do something else. That would work too. Or you can do what we'll talk about in this video. You can run things in the background. Now, the way we run something in the background is we put an ampersand at the end of the line. And that ampersand means give me back my terminal immediately. So you can see I can do the pwd. I can do date. I can do all the things, everything interactive that I plan to do with my terminal. I can do while I'm waiting for that process to end. That process is running in the background. You can see why it's called in the background. It's just finished. It put my output out. Now it just puts it wherever and whenever I am. It could be in the middle of something else. Say I was looking at a file. It didn't actually put it in that file, but it puts it in my screen. And then it gives me a message saying, you see up above in square brackets and a 21139. That is basically telling me, hey, I've started this process. It's the first one you're doing like this. And now it's telling me, hey, that first process you were doing is now done. It was called longscript.sh. That's great if all I want to do is forget about it, but what if I want to do something about it while I'm running the process? So let's do longscript again. I did a Control-C to stop that process. Control-C will essentially interrupt the current process that's going on. Because what I wanted was to run this in the background. And now I can type jobs, and the shell will show me all the jobs that I'm running. I have a grand total of 1 job. And I can do things with that information. So for instance, let's start one more. I actually didn't want to be running that. I wanted to kill it. I don't have to give the process ID number like we normally do with the kill command. I can give a %1. %1 means kill job 1, whatever I see with the jobs. If I had 5 of them going, they'd be numbered 1 through 5. And I could kill number 3, for instance, that sort of thing. And now you see before my process said, when it exited, it said it was done. This time it says it was terminated. It's even telling me, hey, this process did not actually finish. It was terminated before it was finished. One final thing that sometimes happens, sometimes you have something running in the background and you actually want to bring it to the foreground. A good example is if a program needs input from the terminal, that cannot happen when it's in the background. Or maybe you finished other things you were doing and you want to bring that process back to the foreground. So let's show how to do that. Again, we will run our script and run it in the background. We'll do our jobs. We know it's job 1. I can say FG %1, and my job comes back to the foreground, and now I'm just like we were the first time we looked at it. I have the process running in the foreground. I do not have a prompt. The system is waiting for this thing to finish, and it has finished. So that was a real quick look, but it's a pretty simple concept, and that's how to run processes in the background. In this video, we will discuss something called man pages, and that's just a built-in documentation system for Linux. This goes back to the 1970s when Unix was first being developed. And when you got Unix, it came with documentation. And that documentation was several binders of information about various commands and configuration files, programming functions, all the pieces that make up a Unix system. And collectively, that set of binders was called the manual, and an individual entry about a specific command was called a manual page, or a man page for short. And even if it was several pages in the manual, it was still called a man page. That was just sort of the nomenclature that was used. Well, this manual was also supplied in electronic form, so you could just have it on the system and be able to reference. And the command to look at that documentation is called man. And let's take a look at some man pages. First, let's take a look at the man page for the pwd command. It's a fairly simple command. We type pwd, we find out what directory we're in. And this shows a few things about the basics of a man page. The first section is always name, and it gives us the name of the command and a very brief description. Print the name of the current or working directory. We see that the synopsis always tells us exactly how to use the command. We have pwd in square brackets means it's optional. We don't have to say it, but we can supply some options. Then in the description section, we have some description of those options. Use pwd from the environment even if it contains symlinks. Avoid all symlinks. Show some help. Show the version. There's not a whole lot here. None of that really matters to us. Another thing to note, you see we have the manual page, pwd, line 1, press H for help or Q to quit. We're actually running the less command. And what really happens is you get dropped into what is set as your default command to handle things that are longer than one screen. Less happens to be the default in Linux. Who wrote it? Some bugs. Usually a man page is going to end with the see also section that we see down here, which is other things that are like it that also might apply. We're in less, so we hit Q to get out. So let's take a look at a little more complex page. Do one for the uptime command. Tell how long the system has been running. That's the function of uptime. The description's a little longer this time. It's not showing us a bunch of options, but it is telling us basically what the format is, what it is we're looking at when we look at the output of uptime. It's a one-line display. It gives you the current time, how long the system's been running, how many users are logged on, and the load averages for the 1, 5, and 15 minutes. Then they even have an explanation of what the load average is, so you can read that, get a more technical feel for what the load average is. Options. In the previous man page, options were just lumped into the description. Often it's a separate section. We have a -p, show uptime in pretty format. We have a help, we have a since, so when did the system boot up, and a version, display some version information. Files, often if there's files that a program either depends on or uses or affects, that'll be listed there. Again, authors and the cs command or the C also says, hey, if you're interested in uptime, you might also be interested in taking a look at the PS command, the top command. The 1 in parentheses is the section of the manual. It harkens back to the time when it was a physical manual. So commands were in section 1 of the manual. System calls are in section 2. C function calls are in section 3, so on, various sections. utemp, section 5 is documenting file formats or files. So the utmp file, which it reads to see all of its information about who's logged in. That's a page you might be interested in. The W command is a command that gives you a brief summary of what various users are doing on the system. But now we're looking at this and we say, hey, this P, what does the pretty format of uptime? We've done uptime before. Here's the format of uptime. It's just as described. It gives us the time, tells us how long the system's been up, how many users there are, and what the load averages are. So what's the pretty version? Well, let's try that out. Uptime minus P for pretty. It just takes that time and formats it as a more human readable. Not necessarily prettier, but it is more human readable. The nice thing about man pages is they're readily available. They all have a similar format. They're all going to follow that same structure. One-liner description of the command, a very, very terse synopsis of how to use the command, then a description of the command, documentation of all the options of the command. Sometimes there's examples on how to use the command, and then near the end there's going to be that see also section. So it's a predictable format. You know where to find things. If you know how to use a command, that synopsis can be very helpful to know whether there's required arguments, what are the optional arguments, that kind of thing. Just as a general thing for using man pages, because they're designed as a documentation format, what I tend to find helpful if I'm trying to learn about something new, like we did with the uptime. You read the man page, you see something in it that looks like it might be useful, go ahead and try that. Exit out of the man page, try that thing, maybe go back to the man page and reread again and develop your understanding. And you can even kind of iterate on that. You can learn Linux from man pages is what it boils down to. And back in the day, that's pretty much how I learned Unix, was from man pages. Let's do another example. Let's do this one with the man page for the kill command. So we do man kill. It says kill sends a signal to a process. We discussed that when we talked about kill. Kill doesn't kill processes, it sends them a message, it sends them a signal. We see the synopsis, we have options, we have one or more process IDs to effect. That's what the dots mean. And then in the description, it tells us the default signal is the terminate signal. Hey, you need to terminate. That's what the default action of kill is. Use minus lowercase l or minus uppercase L to list available signals. That sounds kind of interesting. And then they even tell us particularly useful signals include hup, int, kill, stop, and cont. And what all those signals mean is beyond the scope of what we're going to do here. So I can list out the signals. And I have a dash lowercase l or dash dash list. Sometimes commands have what they call a long form and a short form. So dash L for the short form or dash dash list. The two dashes tell us this is a long form. It's not the arguments L, I, S, and T all combined. Give us a list of signal names. This option has an optional argument which will convert a particular number to a name or the other way around. So that's kind of handy. If I know the default signal is term, because it told me that, what number is that? Or if I have a number, what thing is that? Dash capital L, list all the signal names in a nice table. We're going to try that here in just a second. And then, like I said before, we have some examples. So here's some examples of kill in various usages, and those can be very helpful. List of other commands you might be interested in using, and bug reports and things like that. So let's try the kill minus capital L to get our list of signal names. Wait a minute. The man page says that kill minus capital L should give us a list. And kill minus lowercase l can translate things. Okay, so there's a big list. That sounds more like the capital L description. We can look through here. We can see, I happen to know, 15 is sig term. That's the default signal. So what was going on with this capital L? If we go back to the man page, it clearly says that capital L lists signal names in a nice table. Yet when we tried it, it said invalid signal specification. The answer to that is actually a little bit subtle, and it's worth pointing this out because this can happen. If I say type kill, type tells me when I run kill, what am I actually running? What's the path to the thing? Or in our case, is it built in? Kill is built in to the bash shell. We're not running the kill that man page is for because bash has its own version of kill. We're actually running the bash version of kill when we are typing kill like this. So if we say /bin/kill, which is the path to kill, now if we say dash lowercase l, we get a list of signals. And if we say bin kill minus capital L, we get the output that sounded like what the man page described. So that's a little tricky sometimes if you happen to be using something that could be built in or could be a command on the system, just something to keep in mind. Now to really overwhelm you with a man page, since we found out that kill is a built-in, let's take a look at the bash man page. Now this thing is long. I'm just going to scroll through it here, just so you can get a feel for how long this man page is. This is everything about bash that you might need to know. We've actually made it to the point I was looking for. This is where it documents all the commands that are built into the shell. So if we go down here, we see the cd command that we use to get around directories. That's not an external command, that's actually built into the shell. Go here a little bit further, we're going to see another one that we have used. FG we used with our background processes, that's built into the command. All the backgrounding and stuff, that happens in the shell. There's jobs, same thing. Oh, and here's kill. So here's the description of kill as a shell built-in. That's the one we're running when we don't say do anything. You see it has optional arguments. We can do -s a signal. We can do -n a signal number. We can just say -signal. We can do one or more PIDs or job specifications. Or we can say kill minus lowercase l and give some specifications of what to kill. And then a description. Send the signal named to the processes named, essentially what the kill command does. Send a signal to the process. And -l lists the signal names. There's no mention of a minus capital L. That's why we got an error when we tried that with the kill command. Man pages are incredibly helpful. They can be a bit daunting, like that bash man page. They can show you everything about a command. If we look at PS, they don't even bother to list all the options that PS has. They just say, yeah, there's lots of options, because there are. And this is another one. Here's options for PS, and they're just going and going and going. Well, obviously, when you read that man page, you're not going to understand all those options. You're not going to be able to take it all in. It's just too much. But maybe you can take in one thing, try it, read it again, take in another thing, try it, read it again, and you can just do that iterative process. Just keep them in mind. Man pages are incredibly helpful and a very useful thing to get used to using. In this video, we will look at the touch command. Touch has one basic function. It updates the timestamps of files. I have a file here called my file. This is a version of the ls command. The -l is for a long format. It displays a lot more information about a file. And we will cover elsewhere in the course what everything means in this output. But for now, I just want to focus on the date and time that you see. That date and time is the date and time that that file was modified. Now, if I run the touch command and give it an argument of my file, the timestamp has updated to the current time. You can see in the bottom right-hand corner, the current time is 1910, and that's the modification time of the file. That's what touch does. It updates the modification time to the current time. That's the default action. If I do a look at what's in the directory, my file is the only thing currently in this directory. So a good question is, what happens if I try to touch something that doesn't exist? So if I touch new file and do an ls, I've created a file called new file. We can look at it. It's a current file. That 0 there, that's actually the size of the file. It's a completely empty file, but it exists. That's one frequent use of the touch command. If you just need a file to exist, you touch file name, boom, there's the file. This is also a good test for permissions. If you need to see if you have permissions in a certain directory, attempt to touch a file there. If you can, then you'll be able to use that directory for whatever it is you're trying to use. The other purpose or idea behind touch is there are some utilities that depend on the modification time of a file. They look, has the file been updated or not? And then they might take some action if the file has been updated. If you want to do that, you could update the file. You could make some change. Maybe you don't actually need to change it. You just need the utility to run again. Touch is a very easy way to do that. You could make a gratuitous change to the file, a change that you don't need to make, but you could make it, but it's just so much easier to touch. We can actually specify a time other than the current time with the touch command. Let's give an example. I'm going to create a file. -t is the argument, and then I give it a timestamp, and I give it with a 4-digit year, a month, a day, an hour, and a minute. So I just said midnight, January 1st, 2001. And let's call that 2001 file. And then if I do ls-l of 2001 file, now, if it's a long time ago, this output format doesn't give you the hour and minute anymore. It just shows you the date if it needs to specify the year. If it wasn't this year, then we just specify the month, day, and the year. That file, as far as anybody knows, was modified on January 1st, 2001. That can be handy too if you want to set a specific modification time on a file. In this video, we will be talking about the rm command. Obviously, we need a way to delete files from time to time, and that's what the rm command does. Rm stands for remove, and it deletes things. Let's just create a file here. I'm just going to use touch to create a file, call it my file, and then I'm going to delete it. Rm my file. Hit return. You notice I got no feedback on that. I didn't get asked for a confirmation. I didn't get anything said that, yes, my file was removed. And that's sort of a general Linux philosophy, at least from the command line. If you typed it, you meant it. Linux isn't going to gratuitously ask me, hey, did you really want to do what you just typed? It's going to do it. Another thing to point out from the command line using the rm command, there's not a trash, there's not a recycle bin. When you say delete, it's deleted. It is gone. There's no easy mechanism to get it back. That said, on some systems, I think primarily Red Hat-based systems, and I don't know if it's for all users or if it's for root, but there are certain conditions where they actually do have rm aliased to a version that does ask for confirmation. And let's do this again. Let's create my file. What they really do is they say, well, whenever you say rm, you really mean rm-i. I says, I want to be asked about things before I delete them. Now rm is asking me, do you want to remove the file called my file? And by the way, it's giving me a little extra information. It's telling me that that file is empty. Did I really want to remove that? Y for yes, and then otherwise it's exactly the same as the regular version. Getting asked is no big deal for, one or two things. It might be just a little bit annoying. But imagine you had a lot of files you were deleting. Maybe you have hundreds of files, and I've been in this situation. It starts asking you about every single one of them. That's pretty annoying. So we're going to look at that situation. I'm going to go here to a directory called dir1, and I've just put 10 files in here. My file 1 through my file 10. Notice that it sorted them 10 follows 1 because it's sorting by alphabetical order, not by numerical order. And I'm going to type rm -i, and I'm just going to give it a star. Star is a wildcard, and it means everything. Delete everything and ask me about it. And so I get asked, do you want to delete my file 1? Yes. Do you want to delete my file 10? Yes. Yes, 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 yes. And this is what happens. You just start typing yes all the time. You blindly say yes, 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 and then you end up trying to type a command called Y, and then the shell says to you, Y is not a command that I know anything about because it doesn't exist. Just an example where it can get annoying. Now, I exaggerated a little bit because 10 is not really that bad, but imagine it with 100 or 200. I'm going to show how to get around that if you face that situation. Here's another directory, basically the same setup. It has 10 files in it. This time I'm going to use rm -f star. And the F is for force, and it means do it anyway. Even if you wanted to ask me, the answer is yes, do it, delete it. And there are some situations besides the just I want you to ask me on all files. There are some situations that we'll get into when we talk about permissions where you will get asked about deleting a file. And the -f says, don't ask me. Even if you need to ask, don't ask, the answer is yes. So I do that. That's just like the very first version, except now I just deleted 10 files with no feedback. They're gone. Be careful with rm. It's very powerful, but it's also very handy. In this video, we will talk about creating and deleting directories. The command to create a directory is mkdir for make a directory. So I can say make a directory called mydir, for example. There's my directory. I now have a directory in my home directory called mydir. It's empty, but it exists. And if you remember your path syntax, that's what we're giving here as the argument, is a path. We're giving a path to where the new directory should be and what it should be called. In this case, I gave a relative path relative to the current directory, and I want to call it mydir. But I can give relative to a directory, so I can say make dir mydir subdir. And I've now created a directory inside the mydir directory called subdir. There's relative paths. I can also do an absolute path. Home Jeff mydir subdir level 3. Now I have a directory inside subdir, inside mydir, inside my home directory. What happens if I give a path to something that doesn't exist? Let's try that. Make dir mydir 2 subdir level 3. I haven't created that. So what happens? I get this error message that says mkdir cannot create directory, mydir2 subdir level 3, no such file or directory. Well, of course there's no such directory. I'm trying to make that directory. Well, it's not telling me there's no such directory level 3 down there. It's telling me that something in the path that I gave doesn't exist. And by default, mkdir needs to have a directory that already exists and the name of a new directory to create there. But there is a workaround for this. There's actually a way to do what I just tried to do. That way is with the flag -p. So if I say make dir -p, p stands for parent directories. Make any parent directories that are necessary. Now I do mydir2 subdir level 3, and it creates everything. And just to prove that it exists, ls mydir2, you see that it exists and it has a subdir. Bring that back up and add subdir. And there's a directory there called level 3. So it created all the directories in that path that were needed in order to make that command work. Now, of course, in addition to creating directories, we might need to remove directories. The opposite of mkdir is rmdir. So if I say rmdir mydir, for example, I'm saying delete my directory, and it says can't do it, the directory's not empty. rmdir deletes empty directories. It doesn't delete directories with things in them. If I look in my dir, of course, it has the subdir in it, and subdir has the level 3 dir in it. So I can't delete a directory unless it's empty. So what I actually have to do is I have to rmdir mydir subdir level 3. That directory is empty. I can do that. Then I can come up here and I can delete subdir. I'm just using the arrow key to bring up the previous command. And finally, I can remove mydir. You can see where that would get pretty tedious if you had some large directory structure that you were trying to blow away a whole big thing with lots of directories and lots of files in it. There is a way to do that as well. It's not an argument to the rmdir command, it's an argument to the rm command. Rm removes files, not directories. So what's up there? Well, we'll show it with the mydir2. rm minus r, mydir2. R is for recursive. And so what you're telling rm to do is to go to a directory, then go to any directories in it, then go to any directories in those directories, etc., etc., etc. Recursing, that's the term for what it's doing. Recursively go through, delete everything in the bottom directories, then delete those directories, and just delete your way back up until you finally delete the directory that I requested. As usual, I'm not given any feedback. I'm not told that I just blew away 3 directories. I just did it. And to prove that I did it, let's look at mydir and mydir2, and we're told that both of those do not exist. In this video, we're going to talk about a very interesting command. It's the command ln. It's for linking files. It creates 2 kinds of links, symbolic or soft links, and hard links. We'll talk about what each of those is, how they work, and that kind of thing. Now, to do this exercise, I've created a file. I called it original. And I just put some text in there that says this is the original file. You can create it with any text editor you're comfortable with. I did it with VI, which is a command line text editor, but you're free to use the GUI text editor. Just create a text file and have it have something in it that you can easily see when you do cat. We're going to use the command ln. Normally, when we have introduced a command, we start with the default behavior, and then we talk about some interesting flags to it. In this case, we're going to start with a non-default behavior, and that's because symbolic links are simpler than hard links. So ln minus s, s is for a symbolic link or a soft link. Those 2 names are pretty much interchangeable. We want to make a soft link. We want to make a symbolic link from original to, and I'm going to call it shortcut. And there's a reason I'm going to call it shortcut, but for now, we're just going to do that. So I've created a soft link. If I cat shortcut, I see what was in the original file. Just to prove that I really am looking at the original file, let's change the original file. Again, I'm editing this in VI, but you can use whatever you're comfortable with changes. And I cat shortcut. And there's my changes. So I really am looking at the file original. I called this shortcut because this works just like a Windows shortcut file or a Mac alias file. It's simply a file that says the file you want is over here. In fact, if I do ls-l on shortcut, the long output format for ls actually shows me it is a soft link and what it points to. So it says shortcut, that little arrow there, and then the real file that you're looking at is called original. Now here's where we'll get a little more complicated. We're going to talk about hard links. It's not complicated to do. Original, let's call it original2. And if I do like this and I cat original2, there's my file. It looks exactly the same. Looks like the same thing as shortcut, but it's actually quite different. We'll walk through a diagram that helps show what the difference is and what's going on here. So what we did, we created a file shown here by the box. We created a file, we put some text in it. This is the original file, and we named that file original. We had some data, we had a name for that chunk of data. When we made the symbolic link, we created a new file. And the contents of that file are basically some instructions that say, go to the file called original for what you're looking for. Now, when we made the hard link and called it original2, what we did was we just made another name for that original chunk of data. So original and original2 are 2 different names for the same chunk of data. Shortcut is another chunk of data that points to the named chunk of data original. So there's an interesting implication in this. What happens if we remove original? This kind of shows pretty clearly what's going on. All we did was remove the name original from that first chunk of data. So original2 is still pointing to that chunk of data, but something interesting has happened to shortcut. Shortcut says go to file original, but original doesn't exist anymore. That link, shortcut, the symbolic link, is now broken, and that's actually the term. It's called a broken link. Let's see what this looks like in real life. First, if I do ls-l, and I'm going to use the tab completion. There's a feature in bash. If I type part of a name, ORI, let's say, and I hit tab, bash will attempt to complete it, and it will go as far as it can. I have original and original2. It goes as far as original and shortcut. That can be very handy when you're typing things and you type enough of the name and then hit tab and you don't have to type the whole thing. I want to look at the output of ls-l on all of these files. We haven't gone through yet in the course what all these things mean on the ls-l output, but I think it's very easy to see that original and original2 are the same all the way across. Everything about them is the same except for the name. That is because those are two different names for the exact same file on disk. Shortcut is a different file, and it happens to be a symbolic link that points to original. Another thing to note is the 2 on the lines for original and original2. Right in front of the first Jeff, there's a number 2, and on shortcut there's a number 1. That is something called the link count. Every file knows how many links there are to it, how many hard links there are to it. The definition of deleting a file is removing the last link. When the link count goes to 0, that's when a file is deleted, and the system considers that disk space to be free. I currently know that I have 2 links to that file, and I happen to know that they are original and original2, but I at least know that there are 2 links to that file. And shortcut is a separate file, just like we saw in the diagram. Let's delete original. And let's cat original2. It is unaffected because it was just another name for the same data. Let's cat shortcut. I get told no such file or directory. ls shortcut. There's shortcut. Shortcut exists, but I get told no such file or directory when I try to look at it. Or, in fact, if I'm going to try to do anything with it, I will get told no such file or directory. What is going on? And this can be a very confusing thing when you first deal with it, because it's there. Why is it saying it's not there? Well, what it's saying is that original is not there. In fact, this particular version of ls happens to color it red. Before it was not red. It was sort of a teal color. Now it's red. It is what is called a broken link. It does not work anymore. So what it's actually telling me is that original is not found. So shortcut is an alias or a pointer or a soft link or a shortcut to a file that no longer exists. That's what the error message is saying. It is sort of cryptic and hard to understand. Now let's do ls-l. Let's look at the long listing format of original2. And the main thing to notice, the link count has changed. We deleted one of the links to that file. Now there is only one link to that file. There's another bit of evidence of what's going on behind the scenes that matches up with that diagram we walked through. Now you might wonder, since a soft link can end up broken like this, and a hard link survives just fine, why wouldn't you just always use hard links? There are actually 2 situations where you have to use a soft link. And those 2 situations are, if you're linking to a directory, you can make a link to a directory, make an alias to a directory, but it has to be a soft link. You cannot make a hard link to a directory. You can only make a hard link to a file. And the second situation is you can only make a hard link between 2 file names that exist on the same file system. That's essentially a drive or a partition, but it's on the same file system is the Linux way of phrasing it. Those are 2 situations, either between different partitions or to a directory where you have to use a soft link. If you're in the same directory like we are here, you can use either or. There are some advantages and disadvantages to the various ones. One of the advantages of the hard link is it doesn't depend on the existence of the original file, whereas the soft link does. Make a directory, do some experimenting with links, review the discussion here, go back over that diagram. This can be a little bit confusing, but I think once you understand it, you'll have a very good understanding of how Linux treats files. It'll help you a lot in understanding some of the nuts and bolts of Linux. In this video, we will talk some more about the ls command. We've talked before about ls, and we've been using it a bit throughout the course, but now it's time to dive into a few more useful options that we haven't talked about. The first thing we're going to talk about is the -l option, ls-l for a long format. It tells us a lot more information about files. As you can see, if I just do this in my home directory, there's a lot of information about all the files and directories that are there. So let's walk through that format just a little bit. The very first character on the far left-hand side tells us what kind of a file or a thing we're looking at. You notice that in my case, it's all either a D or a hyphen. The hyphen is for a regular file. A regular file in Linux can be anything, pretty much anything that's contained in a single file. So it could be a text file, it could be a compiled program, it could be a video, anything in a single file. Directory, like the very first line, ch3, a directory is indicated by a D. Symbolic link, it would be indicated with an L in the first column. And there's a few other types that can show up there. Generally, they're not things that you're likely to come across in day-to-day use, so we're not going to worry about them here, but just be aware that there could be other things. Mostly what you're going to see are the hyphens and Ds and maybe the occasional L. The rest of that first field shows the permissions of the file or the directory. And that's a complex enough topic that we're going to address that in a completely separate video. So for now, just know that it's there. Those are the permissions, the RWX stuff. The next field is the link count. In the case of files, it tells us how many links there are to that file. In the case of directories, it tells us how many directories are in that directory. Files aren't counted, but other directories are counted. Now, if you look down through this list at all the directories, you'll see that all of the directories are at least 2. What is up with that? If I look in, for example, public, there's nothing in there, but it says there's 2 things. Remember, every directory has 2 directories in it, 2 special directories. They are dot and dot dot. Dot is the directory itself, dot dot is the directory 1 level up. And those are counted as 2 directories within that directory. The next column is the file owner. Every file or directory is owned by a user on the system. In this case, it's my home directory. It's kind of uninteresting. All the files are owned by me. Not too surprising. The next column is the group. I know it looks just like my username again, but that's the group. Every file or directory, again, is associated with a group of users. And by default on Linux these days, every user gets their own group. It could be something different, and there are cases where you use something different, but like for my home directory, it's in the group Jeff, which has 1 person in it, which is Jeff. The next column is the file size in bytes. For a file, that's really easy. The killme.sh is 174 bytes. Very easy to figure out. For directories, there's actually a file that defines a directory, and it's allocated in chunks. And the size you see for a directory is the size of that file that defines the directory and its contents. I think in every single case of my directories, they are 4096. Turns out those files are allocated in chunks, and the chunk size that's being used on my system happens to be 4 kilobytes. It allocates a 4 kilobyte chunk for directory, and then if it needs to expand beyond that, it'll go to 8 kilobytes, etc. So a very big directory could be much larger, but the 4K is fine. The next column you see is the modification time of the file. If it's recent, the modification time is shown like you see here as a month and a day and a time. If it's an old file, what you'll see there is the month, the day, and the year for something that's very old. And finally, we have the name of the file or directory. In the case of a soft link, we would also see where the link points to. And you'll notice my output happens to be colored. That's a special feature that you may or may not see. So if it's executable, it's green. If it's a regular file, it's white. And if it's a directory, it's blue. There's some other colors that can be in there to help you visually distinguish the things in your directory. Sometimes we have big files. We're going to take a look at a directory called /boot. And the main thing that we want to look at in there, this is where Linux itself is. The thing that starts up when you start Linux is contained in this directory. And you can see there's some big files. I don't know about you, but when I look at, for instance, the initrd, and I see a number of 289.67705, I have no idea how big that is. That number is kind of meaningless to me. It's so big that it doesn't mean anything. And it's not delineated in any way. I actually have to count from the right. So it's 28,967,705. It even takes me a minute to figure that out. Well, there is a nice option to ls. If we add an H is for human, and it says, give me sizes in a human-friendly format. That file's 28 megabytes. The config is 162K, 3.3 megabytes, 5.6 megabytes. Those are numbers that are far more meaningful to me. So that's a very handy option. The next option we're going to look at is a -R. And the R is for recursive. And this provides a recursive listing. Very simply, it lists the directory and then it traverses everything below that directory. So if I just say, again, back to my home directory, ls-r, I see everything in my home directory, and then it goes to all the subdirectories and the subdirectories of the subdirectories and that kind of thing. We can combine that with -L, and we can get the same thing in a long format. And those ones with question marks are because I don't have permission to see that. So we'll go up here to where there's something a little more interesting going on. So you can see I get the long format listing of everything recursively under my home directory. So what if we want to see the listing for a directory? So for instance, my home directory. Now I could say ls-l. If I say home Jeff, I'm going to see the contents of my directory. If I say home, then I can see that Jeff is one of the things in there. But there's another option I can do, and I can say ls-ld, and if we remember that tilde is a synonym for my home directory, the D says, show me the listing of the directory itself. It's the same information as when I looked in /home, except I have specifically said I want to look at that directory. So we could do the same thing, ls-ld, /boot, and we can see what the permissions are on the /boot directory. D works with or without the long option. It's a little less interesting without the long option because you're just looking at it. But again, if I wanted to see that directory as opposed to the contents of the directory, I add -D. There are a lot of options to ls. If we look at the man page, they don't even bother to list them in the synopsis. There are a ton of options. And there are a lot of other things you can do with ls. But at this point, we have covered the most commonly used options. And if you stick with the ones we've had here, that's going to be 95, 98% of all the use you'll ever need to make of the ls command. And with that, we conclude our discussion of ls. In this video, we will talk about file permissions and something called the mode of the file. Now I'm in a directory here called permsdir, and I've just created a number of files that have various permissions, and we'll just talk about these permissions as we work down the directory. Permissions, that's the RW and X stuff in that first column of the ls-l output. And the permissions are stored in something called the mode. It's actually 12 bits of data that are associated with every file that fully define all the permissions. And basically the permissions are divided into 3 sets. So you see there's an RW and an X, an RWX, RWX. There's 3 sets of permissions. The permissions are R for read, W for write, and X for execute. So there's 3 groups of 3 permissions. And if a particular permission is set, in the ls-l output you see the letter. If it's not set, that's where you see the dash. Now read permission, that's pretty obvious. It stands for being able to read the file, or being able to access the contents of the file. It may not be a text file, but you may still need to be able to access the contents of the file. Read permission gives you that. Write permission, fairly obvious probably, that means permission to modify the file. And finally, execute permission, it applies to executable files, obviously, and it means that you have permission to execute that file or that program. One special thing to note, if the file is a script, like a shell script, a Perl script, a Python script, a Ruby script, anything that's a plain text file that's intended to be used as an executable, in those cases you need both read and execute in order to execute the file, because you have to be able to access the text of the script as well as execute the script. So in these 3 groups from left to right, the first group is for the user who owns the file. The next group of permissions is for members of the group associated with the file. And the third group of permissions is for everybody else. So let's walk through the directory and discuss the permissions that we see. So the first file, everyone. We can see the permissions are read and write for all 3 groups. The first group, the owner of the file is Jeff. The owner of all the files is Jeff, and the group of all the files is my group, just to make this discussion easier. Jeff has read and write permission. Members of group my group have read and write permission, and everyone else has read and write permission. The next file, group look only, we see user Jeff can read and write the file, and members of the group my group can only read the file. They can't make any changes to it, but they can look at the file, and everyone else cannot do anything with the file. They can't look at it, they can't change it, they can't do anything. For the file just me, Jeff, can read and write, and no one else can do anything. We look at look only. This is actually a fairly common permission that you see on the look only. I have permission to read the file and make changes to it, and I've made it publicly visible. The members of my group can read the file, and everyone else can read the file. For the file my group, maybe this is some group project some of us are working on together. So I've given read and write permission to myself, and I've given read and write permission to the members of my group. But other people cannot see the file or do anything with it at all. The final three examples give some common permissions for executable files. The first one, x by all. This is something that I'm allowing anyone to execute, anyone to do anything with, except I'm the only one who can modify it. And the next one, x by group, I have given read, write, and execute to myself, so I can do anything with the file. The members of my group can read and execute, and the other people can't do anything with it. And then finally, the x just me. All these names obviously give some clue as to what the permissions are, but x just me, I'm the only one who can do anything with it. I can read, write, and execute, but nothing else. That's our introduction to permissions on files. Remember, it's the three groups for the user, the group, and everyone else, and the three permissions, read, write, and execute, and all the various combinations that those can do. In this video, we will talk about directory permissions. Directory permissions use the same three sets of three permissions, read, write, and execute, for the user, the group, and everyone else. And they're stored in the same sort of structure, the mode. The question becomes, for directories, if it's using the same permission structure, what do those permissions mean? What does read mean for a directory? What does write mean for a directory? And what does execute mean for a directory? So I've created a directory here. I have a handful of subdirectories, and each of those has some different permissions about them that we'll talk about. Normal directory is there as sort of a, normal directory. Normally, if I own a directory and I give access, if you have access to a directory, you either have read, write, and execute, or just read and execute. So in the case of normal directory, I own it. I have read, write, and execute. Everyone else has read and execute. Basically, the difference is whether you want to give write permission to people. Write permission would allow them to make changes to the directory. And you may notice most of these directories are owned by root. Root is the system user, the user that owns everything in Linux. They all have group Jeff, and the reason I've set it up this way is so that the permissions that apply are not the permissions of the owner in most cases, except for a normal directory. They are the permissions of someone else, of the group. I've made the group and the others the same permissions. So those are the permissions that are going to apply as we talk through this. First, let's talk about normal directory. I have full permissions. That's going to be kind of our baseline. I have read, write, and execute on that directory. So what does that mean? Well, it means I can do ls. I can see what's in the directory. I can access something in the directory. It's just a text file that says this is a file in the normal directory. And I can create a file in that directory, and everything's there. We'll talk about that do not touch file in a little bit. So those are sort of the default permissions, being able to look at files in the directory, being able to access a file from a directory, and being able to make changes to the directory. Now let's take a look at the read execute directory. Now I only have read and execute permissions in that. I don't have write. So let's see what that does. I can do an ls. That's just fine. I can look at that file. Now, of course, the file permissions themselves are going to come into play on that. The directory permissions matter too. We'll talk about that in just a minute. I can do ls, I can access files, but can I create something? No, I get permission denied. That's because I need write permission in order to be able to create files, rename files, or delete files. Those are all changes to a directory. What happens if I only have read permission? I have this directory read only. I only have read permission on that directory. So if I do ls of read only, I get an error message that says permission denied, but then I see the file there. That's telling me that there is a file in that directory called file. So if I was able to see that there's a file, why did I get permission denied? This will be a little more clear if we do ls-l. ls-l on read-only. We get the permission denied on read-only/file. Then we see that there is a file there, but we get no information about that file. We know that it's a file. That first column's a hyphen. We don't know what the permissions are. We don't know who the owner is. We don't know who the group is. We don't know the size of the file, and we don't know the modification time of the file. We just get question marks for that. This is something you can't see, but the file called file in every one of these directories is identical. It looks like this one in normal directory. What really is the case is I have read permission on that file. I am allowed to look at that file, but I wasn't able to get any information about it. What's going on? That is because I did not have execute permission on the directory. And I can't cat the read-only file. I get permission denied. Again, if we look at the file permissions, if we could look at the file permissions, I would have read permission on that file. But I get permission denied when I try to access that file. And that is because execute permission on a directory is needed to access a file. Whatever the permissions on the file are, I have to have execute permission on the directory. In fact, I have to have execute permission on every directory in the path to the file. So you could almost consider it a mistake if you saw read-only permission on a directory. It's almost always read and execute, if it's anything at all. And finally, we'll prove it. I can't create a new file because I don't have write permission. The remaining directories all have some sort of quirk about them that will just highlight some features of directory permissions. In the normal case, you either have read and execute or you have read, write, and execute. And the difference is whether or not you're allowed to make changes to that file. Or the third alternative is you have no permission on a directory. Because read and execute kind of go together. We've looked at a read only. How about an execute only? If I do an ls on execute only, I get a permission denied on that directory. I don't have read permission, so I'm not allowed to see what's in that directory. But I said before, I have made a file called file in every directory. First of all, tab completion, I'm pushing tab here. Tab completion isn't working because I have to be able to read the directory to do that. But if I know the name of the file, and I have permission on the file, and I have execute on the directory, I can access that file. It's kind of an interesting little quirk. I may not be able to look in the directory and see what the files are called, but if I know they're there, I can get to them if I have execute. By now you should be able to guess what happens in read write only. I can do an ls, I can make changes to the directory. But you notice that this particular version of ls has highlighted that directory. It's really just saying, these are weird permissions. I don't know what you're doing here. I can create files, I can rename files, I can delete files, but I can't actually access anything in the directory. That's why it's considered weird. The final thing we want to talk about with directory permissions is a potentially confusing implication of all this. So let's go in the normal directory. We have some files here, and I have read permissions on file. I just created new file. I have read and write on it. But there's a file do not touch, and I do not have permissions on that file. I have no permissions whatsoever. If I try to cat it, I get permission denied. Obviously, if I wanted to make changes to it, I can't do that either because I don't have any permission on it. But I can delete it. Now I'm being asked a question. I'm being asked, do I want to remove the write protection? When we talked about RM, we mentioned there's a -i flag that will ask you about things. Normally, the default of RM is not to ask you, but it will ask in cases like this. I have permission to remove this file, even though I don't have any permission to the file itself. Why is that? RM is flagging this situation. It's saying something is a little bit off here. You are given permission to remove this file that you don't have any permission for. So do you really want to do it? Yes, of course I want to do it. That file is gone. So what's going on? If we look at the directory permissions, I have write permission to that directory. And that's the only permission I need in order to delete a file. I do not need to have any permission on the file itself. Once you understand that, you can delete a file that you don't have any permission for because it's the directory permissions that matter, not the file permissions. I think if you understand that little anomaly or paradox or whatever you want to call it, if you understand that situation, I think you'll have a really good understanding of directory permissions. In this video, we'll talk about special permissions. We'll talk about a special user called root, and we'll talk about some ways to temporarily elevate permissions when needed. Hopefully, as you're going through this, you're using a user account that you created when you installed Unix, like my Jeff account. That's a nice safety precaution not to use a privileged account like root for everyday things. But there are things you have to be a privileged user in order to do, and that's what we'll be talking about in this video. Now in Linux, the administrative user is called root, and root has permission to modify any file, delete anything, run anything. Root truly owns the system. When you need to do something that requires root permission, because there are things like a lot of administrative tasks, you could log in as root if you know the root password. That's one way to do it. But there are times maybe you just need to do one thing, or you need to do just a few simple things. And there are simpler ways to accomplish this than logging in as root. For an example, we're going to look at root's home directory. Root's home directory is in /root. And if I try to look at what's in there, I get permission denied. If we look at the permissions on the directory, we see that root is the owner, root has read, write, and execute, and nobody else has any permission on it. That's entirely appropriate for something like the administrative user's home directory. It's only visible to that user. But there is a command called sudo, S-U-D-O, and root is often also called the super user. So this mnemonic for sudo is do something as the super user. It's likely that you have permission to run sudo. There are special permissions required to be able to run this command. But if you set up your account as an administrator when you installed your Linux, you probably have this permission. If you're on a shared system, if you're on a system that's provided by somebody else, you probably don't have this permission. So that's just something to know. The sudo command runs something as the super user, which is, again, just another name for root. And the syntax is sudo, then whatever you want to run. So let's try the ls again. Now sudo is going to ask me for a password. It asks me for my password, not root's password. I give my password and I look at root and it turns out there's not actually anything in there, but let's confirm that. Let's do a sudo ls-a/root. There's definitely stuff in there. Now you'll notice I didn't get asked for my password again. That's pretty handy if you're going to be doing several things. By default, anything run within 15 minutes, it will stay good. So it will not ask for my password for 15 minutes. If I let it sit for more than 15 minutes, then I will get asked for my password again. The second thing to note, of course, is that our ls command did indeed work. There just wasn't anything that showed that didn't start with a dot. Now, there are other ways of getting special permissions, and those don't require you to do anything. They just happen automatically behind the scenes. And these use some extra permission bits. Now, when we've talked about permissions, you may remember we talked about the mode. And at one point I said that it was 12 bits that are stored in association with a file or a directory that define the permissions. And then we talked about 3 sets of 3 permissions. That's 9 things. So what are the other 3? We're going to talk about those now. Those 3 extra permissions, those 3 extra bits that are in the mode are called the setuid, the setgid, and the sticky bit. Let's take a look at each one of those in turn. On a Linux system, your password is stored in encrypted form in a file. And the file it's stored in is called the shadow file. And it's in etc/shadow. And you can see root has permission to make changes to it. And members of the group shadow can read it. Nobody else can do anything with it. So only root can make changes to your password. Well, what about if you run the command to reset your password? There's a command password, passwd, and change your password. If only root can change your password, how does that work? Well, let's take a look at the permissions on that particular file. It's in user bin. If you take a look at the permissions, see that the first set of permissions is RWS, not X. And that S is telling us that the setuid bit has been set. What is the SUID bit? What it means is when anyone runs the password command, they will take actions with the effective user ID. They will have the permissions of the owner of the file, the user, So you will have root permission while you are running that file. So that file takes your input, asks for your old password, and then it asks you twice for your new password, and then it saves a change to that shadow file, assuming that everything was successful. And the only reason it can do that is because of this guy, this setuid bit right here, because it has root permission in order to do that. I don't have to do anything with that, and there's no special permission needed by people. It's a special permission needed by that operation. So we don't have to give everyone root permission. That would be bad. In a big multi-user system, we don't want everyone to have administrator level permissions, but they do need them for tasks like setting their password. So that's what the setuid bit is for. Now, the next command we're going to talk about is a command called wall. Wall has an S in the group section. That's called the setgid bit. If that bit is set, then the effective permissions of the group are used for when that particular program is running. The wall command is a way to write to everyone's terminal session. So I can say wall, and I can say, hi, everybody, Control D to end, and I can send a broadcast message to everyone logged into the system that says, hi, everybody. Needless to say, this is something to use sparingly because this is a real easy way to be a jerk. We don't want you to be a jerk, but this program exists and it's a way to broadcast a message to everyone that is needed, usually for administrative purposes. But the point that we're bringing this up for, that program needs permission to write to everyone's terminal session. Well, that special group TTY allows it to do that. And the setgid allows when we run the command wall, we have the permissions of that TTY group. So we have the permission with the wall program to write to everyone's terminal session. The final bit that we want to talk about is the sticky bit. The sticky bit is kind of interesting. For executables, it really has no purpose on Linux. It will come back to it when we talk about directories. We have these bits, and we've talked about their application to programs. Let's talk briefly about how they apply to directories. Really only the setgid and the sticky bits do anything with directories. The setuid doesn't really have any meaning for a directory. But with the setgid, when a directory is setgid, all new files created in the directory will have the same group assignment as the directory. So this is really handy if you have a group that's collaborating on files and you make a directory and you want to make sure that everything in that directory is accessible by the group. You make the directory setgid. Now, finally, the sticky bit. We talked about it. For executables, it had to do with whether things remained in memory or not for executables, and that feature is just not used on Linux. But it does have a very important use when applied to directory, and it has nothing to do with things remaining in memory or anything like that. You may remember when we talked about directory permissions, you have the ability to delete a file as long as you have write permission in that directory. It doesn't matter who owns that file. It doesn't matter whether you have any permissions on that file. You can delete a file. That's fine if it's my directory, but what about the temp directory? There's a directory called /tmp for temp, and it is a directory that is shared by everybody, and it's for temporary files. You can see the permissions here. They are read, write, and execute for everybody. The execute bit has this little T that tells us that the sticky bit is set. And what the sticky bit means for a directory is there's a little extra permission. Anyone can add files to the directory. The write permission applies. But only the owner of a file can delete files. That's what the sticky bit means. So the sticky bit tightens up those permissions just a little bit for things like a shared directory and prevents you from being able to delete other people's files, which for obvious reasons would be a bad thing. So there's our extra permission bits, setuid, setgid, and the sticky bit. In this video, we will talk about how Linux deals with users and groups. We've talked a bit about users and groups in regard to permissions and things like that, but we haven't really gotten specific. What exactly is a user? What exactly is a group? Well, it's pretty easy to say a user's an account, but how's that defined? Well, there's a file. It happens to be called the password file, and let's take a look at it. Now first, note the spelling of password for the password file. It's in the etc directory, etc, which is where a lot of configuration stuff is stored. If we look at the permissions on this, we see that root has permission to modify it, but everybody else has permission to look at it. And that's because this is where all the accounts are defined. So if we are going to know anything about other accounts, we need to be able to read this file. It's called the password file because once upon a time, all the encrypted passwords for a user were also stored in this file. But because the file has to be readable by everyone, it turned into a bit of a security problem as computers got faster and faster and faster. It used to be good enough that the passwords were encrypted, and it didn't matter that people could see the encrypted password. But as time went on and computers got more powerful, it became a fairly easy task either to decrypt the password or just brute force guess the password. Now the passwords are stored in another file that is only accessible by root. And we'll talk about that in a minute. I'm going to use a command called grep, which is basically a search command. It lets me search for things in a file. And I'm just going to look for the string Jeff in that file. I'm going to pull up my account information. Here is my line in that file. There's one line for every user and a few things to see. You can see that it's got several fields and it's delimited by colons, the full colon. The first field is the account name. The account name is Jeff. The second field where that X is, that is where the encrypted password used to go. Now it is stored in a separate file and there's just a placeholder there. The third field is the user ID number. Every user has a unique number, it's just an integer, a unique number, a user ID, UID for short. And that's what actually matters. When a file is defined to have an owner, what's stored is the UID of that owner. Same thing with a process. When a process is owned by a certain user, it's the UID that is associated with that. So like when we do ls -l and we see the names in there for file ownership, that's because the ls command has gone and looked in the password file and found out what the names are for all those user IDs that are associated with the files. The next column is the group ID, the GID for short. This is the primary group that a user is a member of. You can be a member of multiple groups, but whatever is specified here will be the default group for any new files or any new directories you create and that sort of thing. The next field, sometimes called the comment field, it's the user's full name and potentially some other information, and that's why the commas are there, because they're there for the other information, which isn't defined in my case. The next field specifies the home directory, /home/Jeff is my home directory. And finally, we see the shell of the user. In my case, it says the shell to use is /bin/bash. What that applies to is when any user logs in, the system looks at that last column and runs that program as the final thing when the user logs in. And that defines what the user does when logged in. In most cases, it's a shell like bash. Or, let's take a look at the file. We see a lot of different users are defined in here. And if you look at that far in, you'll notice a lot have defined a shell of user sbin no login, and a lot have defined a shell of bin false. Now, what's up with that? Turns out that both of these are a way to make an account that can own files, that can run processes, but can't be used to log on. Both those commands, no login and false, you run them and they immediately exit with an error. So even if you could log into them, you can't do anything. Let's just take a look at the man pages here. So if we look at the man page for no login, we see it displays a message that an account is not available and exits non-zero. It is intended as a replacement shell for accounts that have been disabled. False is very similar, except that false doesn't actually display anything. It just exits with a status of failure. So both of those basically say go away. Now you might guess if there's a command called false, maybe there's a command called true, and it is true. There is a command called true, and true does exactly the same thing, except it returns with a true exit value. So anyway, that's the password file. There's an entry there for every user known to the system. Some of those users might be people. Now, the group file is very similar, and we're just going to take a look at that. It's called etc group, and there are fewer columns in the group file, and the first field is the name of the group. So there's a group called Jeff, for example. There's a group called my group. There are various groups, again, for systems stuff. The next field where there's an X, that is a password field. There could be a password applied to a group. Again, it would be an encrypted password. This isn't used very much, so most of the time, almost 100% of the time, you're going to see an X there. Next, we have the group ID. Like the UID, that's just a number that defines the group. It's what's stored in a file or in a directory's permissions, etc. And finally, there is an optional comma-separated list of users who belong to that group. So on my system, it's pretty basic. I don't have any real interesting groups, but there could be multiple people listed in a group. So for example, if you had a group called Stooges and you had 3 users called Larry, Moe, and Curly that were members of that group, what you'd see there in that last field is Larry, comma, Moe, comma, Curly. And any of those would have access to anything that was usable by the Stooges group. In this video, we will talk about changing permissions on files and directories. We've talked about those permissions. What are they? What do they mean? But how do we specify them? We're just going to create a file to work with. I'm going to call it my file. I'm going to create it with touch. It doesn't really matter. It just needs to exist and be something we can play with. So if I do ls-l on my file, we can see the default permissions. I have read and write permission. Everyone else has read permission. What if I want something different? I need to be able to specify the permissions. And the command we use to do that is chmod. It's usually pronounced chmod. What in the world's a chmod? What does chmod mean? Chmod is short for change mode. You may remember when we talked about permissions, we said there's 12 bits of data that specify the permissions. And that 12-bit chunk of data is called the mode of the file. Now we change the mode. We're specifying the permissions. We change the mode. Change mode is a big long word, so they just shortened it to chmod. So the chmod command is what we use to manipulate those bits in the mode. And there are 2 different kinds of syntax, 2 different ways to specify what we want to do in the chmod command, 2 variations. One variation is a little more complex to use or to specify, but it's easier to understand. And the other syntax is much easier to specify, but a little more complex to understand. So first, let's look at the one that is the easier to understand syntax. The argument I want to give to chmod, I specify either user, group, or others, or I can specify any or all of them. I can specify 1, 2, or 3 of those. So the U is me, the user, the owner of the file, and we don't say O because we need the letter O for others. So it's not owner, it's user. The G for the group and O for others. So those 3 sets of permissions. What do I want to do? I can either add or remove. In my case, I'm going to add. And then what do I want to add? Read, write, or execute. This is saying for user, group, and others, add the write permission. And then finally, I have to say what I want to do it on. We look at my file. Now we see that the write permission has been added for everybody. It was already there on user. No big deal to add it again. How about if I want to remove permissions? Let's say I want to remove all the permissions, the read and write, for the group and others. Take this file private. I don't want anybody else to be able to use it. Take a look. There we go. I've made the permissions go private. It's a very easy to understand syntax. I just specify who I'm doing it for, what I'm doing, adding or removing, and then which permissions I'm adding or removing. But now the other syntax lets us specify the entire permission set all at once. And it's actually the original syntax of the chmod. This syntax we just talked about came a little later. The original syntax was just to specify those 12 bits, specify the information in the permissions, and to do it as an octal number. I don't want to make anybody's head spin too bad, but if we envision each of those sets of permission bits, there's 3 bits. There's the read, the write, and the execute. And if we imagine it's a 1 for set and a 0 for not set, then we have a little 3-digit binary number. That lets us make the digits from 0 through 7. So that's an octal digit. So it becomes very easy with any one of those numbers 0 through 7, we can specify all the various combinations of read, write, and execute. I made a little file here. On the left-hand side, I have made all the various combinations of 1s and 0s. And then in the middle, I have put what those look like if you say a 1 is either read, write, or execute is set, and a 0 is that it's not set and it's a dash. And then finally, what that single digit is that represents it. 0 is nothing set, for example. 5 is a very common one. 5 is read and execute are set. You can see what it looks like in binary. It's 1, 0, 1. Now, in real life, you don't necessarily need to know all of these. 0, 4, 5, 6, and 7 are the most commonly used. If you use the chmod command a lot, you're just going to start to learn what those mean. Here's how we use that syntax of the chmod command. I could say chmod 640. I say I want the permissions to be 640. So I want the user permissions to be 6. We can look at our little cheat sheet. That's read and write. We want the group permissions to be read, the 4, and we don't want the other people to have permissions. Let's look just at my file. You can see there's the 6, there's the 4, and there's the 0. And there's a few combinations that pop up fairly commonly. 644, 755, 640, 750. Those are some pretty common combinations that pop up. You kind of get used to again if you use this a lot. So now there's one special permission that we need to talk about, and it's a permission that's not specified in the mode. I can actually say, take away all permissions. Let me do that again, ls-l my file, so we don't confuse things. Okay, let's just put that up there. There are no permissions. Nobody has any permission to do anything with this file. It's just straight dashes all the way across. I set the permissions to 0, 0, 0. What does that even mean? Well, it means anything I want to do with this file, I'm going to get permission denied. It's kind of a meaningless thing, but it lets us set the example. Because there is one permission that, like I said, is not specified in the mode, and that is the permission to set the permissions. The permission to set the permissions always belongs to the owner of the file. Since I am the owner of the file, 640, let's say, my file, I can always set those permissions, even if I don't have permission to do anything with the file, as I did in that case. And that's a permission that cannot be granted to anyone else. It is only for the owner of the file. The other thing that I can change as the owner of the file is what group those permissions apply to. By default, it went with my default group, which is Jeff. But maybe I want to associate this file with another group. There's other people I want to be able to read my file, not the people in group Jeff. So now the only catch is I have to be a member of the group. There's a handy command ID that lists all the groups that I'm a member of. Let's just, for example, use the group CD-ROM. chgrp is change group to CD-ROM of my file. And then if I do an ls-l of my file, the group that's associated with that file now is CD-ROM. Change group is a permission that only the owner of the file has. Now the final command to look at in this video is we had chmod, we had chgrp, and we have chown. Chown changes the owner of a file. And the syntax is you give a name of the user that you want to change the owner to, and then you specify the file. If I try this as myself, I get operation not permitted. Non-root users are not allowed to change the owner of a file. That is a permission that is reserved exclusively for root. Now, why would that be? There's a couple of bad things that could happen if I can change the owner of a file. If there are disk quotas in place, I could hide some files by changing the owner to somebody else. Then I'm allowed to store files and violate the quota because the files would get charged to the other person. That's a somewhat bad thing. The worst thing is I could maybe put files in someone else's path and cause them to execute a command that wasn't the command they were thinking if I'm allowed to change ownership of a file to them. The default is that's not an allowed permission. There's just bad things that could happen if I'm able to give files to someone else. There's no guarantee that I'm going to be trustworthy in that, is what it boils down to. So only root can change the owner of a file. Let's do it with sudo. Sudo chown nobody. Nobody is actually a user on the system. There is a user called nobody. Give my password. Now if I look at my file, now my file is owned by nobody. So nobody is somebody on Linux. Nobody's actually a special user that basically has no special permissions. And I'm just using it for an example here. So there you go. Chown, chmod, and chgrp are the ways we manage the permissions, the ownership, and the group on files and directories as well. In this video, we will talk about how to manage users. Now, in the old days, the way we managed users and groups was by editing the password file, the group file, creating a directory in the home directory, setting the permissions, all those kinds of tasks, all those little things that have to happen for a user, we did by hand. Nowadays, there are utilities that help with that. Most notably, there are GUI utilities. If I go here on my menu and I look at administration, there's a users and groups tool, and it says to add and remove users and groups. That's obviously the easy way to do it. But that's a GUI utility. And this is not about GUI, this is about command line. So we're going to learn the command line way to do it. These three files, etc password, etc group, and etc shadow, all have to be modified in order to create a user. And you notice that the only person who's allowed to modify those is root. The other thing is we have to add something to the home directory, and the only person who's allowed to do things in the home directory is root. The end of all of that is we have to be root in order to add a user. And in fact, if we open that GUI utility, the first thing it's going to do is ask us for our password. Because behind the scenes, that GUI tool is actually running sudo. It's actually running sudo and elevating your privileges to root. And from the command line, we're also going to need to run sudo. The command to add a user on Debian systems, which includes Ubuntu and Linux Mint, there are actually two commands for adding users. One is called user add, and one is called add user. Nice and confusing. And they are different commands. They work differently and they behave differently, and we'll look at the two of those. On Red Hat-based systems, both commands exist, but they are synonyms for one another, so it's a little less confusing there. Let's take a look at the man page for user add, and it says create a new user or update default new user information. And it also says under the description, it's a low-level utility for adding users. On Debian, administrators should usually use add user instead. We're going to do it both ways just to show the difference. And so we're going to start with user add, Larry. And I get this not terribly helpful error message. I get permission denied, cannot lock etc password. Try again later. Well, the solution is, and I should know, oh yeah, I need to do something with password. I need to be root. They said it was a low-level utility. It's not being super helpful here. We can do sudo, user add Larry. I have recently done sudo, so it didn't ask me for my password. We have now created a user called Larry. He exists in the password file. There he is right at the bottom. He's got a user ID of 1002 and a group ID of 1002. If we cat etc group, we see that group 1002 is group Larry. Larry exists. If we look at /home, it said his home directory was /home/Larry, but that actually doesn't exist. User add did not create that directory for me. And the other thing user add didn't do, you notice we didn't specify a password for him. If we look at the shadow file, I need to be sudo for that. If we look in there, he's there, but he doesn't have an encrypted password. The second field here, this big long thing there on me, that's my encrypted password. Larry just has an exclamation point, which basically means he has no password. He cannot log in. It didn't completely do everything, and it didn't take care of all the details we wanted. Let's try the add user directory, and let's see how that command differs. We're going to add user mo. The first thing that happens is we get a much better error message here. We get, hey, you have to be root. So that's a much more helpful error message. Add user mo. And we see a few things happening. It tells us some things that it's doing. It tells us it created the user, that it's added a new group, and it's creating the home directory and putting files in it. etc is basically a skeleton, a default home directory for users. And it wants a password. So we'll put a password in there. We enter it twice. This is Mo. He's in room number 13. And we'll leave the other information blank. Is that correct? Yes. The add user command actually ends up running user add and doing all those things. But it just is a little bit nicer front end to it. So now if we cat etc password, we see that Mo is there. He's a little better specified out than Larry was. He has his comment field filled out. He has a shell. That's the other thing with Larry. Larry didn't even have a shell defined. If we cat etc group, they look the same. Created a group for both of them. If we look at /home, we see that Mo actually did have a home directory created. And if we look at the permissions are right on Mo's home directory, etc. Add user definitely seems to do more and do a better job. So we'll take that advice. We'll say, yes, we should be using add user. So we'll do sudo add user curly. Give him a password. He's curly. Leave his other information blank. And now we've created curly. So we have three users, Larry, Mo, and Curly. You can see where I'm going with this. If we look in the password file, there they are, Larry, Mo, and Curly. Larry has some problems, but he doesn't have any name info. He doesn't have a shell. If we look at the shadow file, we also have the problem that Larry's password isn't set, Mo's and Curly's are. If we go back to the man page for user add, we see that with user add, we could have specified some things. We could have specified a home directory. We could have specified create the home directory if it does not exist. We could have specified the password. We could have specified the shell. All these things we could have done. There is a command called user mod. User add adds a user account. User mod can change an account. Basically, all the same options exist. And that -s for shell. So we could say sudo user mod -s/bin/bash Larry. Now Larry has a shell defined and various things. So any of those things in user mod, we can do something with. And we could do the same thing with the comment field, etc. And there's a bunch of other things that we could do. We're not going to delve into those at the moment. Now you might guess, since there's a user add and a user mod, there's got to be something to delete users, right? And if you were to guess, you might guess it had a name like userdel. And you would be exactly right. Sudo userdel Larry, sudo userdel Mo, sudo userdel Curly, cat, etc password, and they're all gone. Userdel just gets rid of them. But if we look at /home, it doesn't actually delete their home directories. There might be something in that home directory that needs to be saved or archived some way, so by default, it does not remove the home directory. There's one more thing that we need to talk about. We're going to redo the user add of Larry, and you recall that one of the things that didn't happen with Larry is that he doesn't have a password set. The command to change a password is called password, and regular users can use this. Use it with no arguments, and it changes your own password. It'll ask you for your old password, and then it'll ask you for a new password and ask you to repeat the new password to make sure it's got it right. But we're not going to do that. We're going to change another user's password. Now, root is the only one who can do that. Root can set another user's password. So if we say sudo password Larry, we are not asked for the old password, and we never will be. If you are root, it is assumed you can set a password. So this is actually how, if somebody forgets their password, you do this as root, you set a new password for them. There's no way to find out what their old password was. You just have to set a new password for them. We are going to set a password for Larry, do it twice. And now if we sudo cat etc shadow, we see Larry has a password. In this video, we will look at commands for managing groups. First, we need to have some users to add to our group. I have created 3 users, Larry, Mo, and Curly. You see them here in the password file. If you currently don't have them on your system, go ahead and create them if you want to follow along. Now, the command we're going to use to create our group is called group add. Not too surprisingly, we had user add, user mod, user del. We also have a group add. We can take a look. Hopefully you're noticing a pattern here with all the names. There's a few options, and we're really not interested in any of these. We're just going to take the default. Sudo group add stooges. Now, if we look at SE group, we see that a group called stooges exists. Our group is defined, but there's actually nobody in this group. The 2 ways to be in a group are to have that group listed as your default group in the password file, and the second is to be listed as a member here. And there's nobody that fits either of those 2 categories. Larry, Mo, and Curly are all in their own group, so the Stooges group is a new group and is its own thing. Now you might think, if we follow the pattern, that there's a group mod. Yeah, there is, but it does the things that group add does. It can change things about that group definition in Etsy group, but it doesn't add users to the group. What adds users to the group is user mod. That may seem counterintuitive, but we're changing the user. We're adding that user to a group. Now, if we take a look at user mod, and we scroll down here to the capital G, a list of supplementary groups which the user is also a member of. Each member is separated from the next by a comma with no intervening white space. So that's the command we're going to want to use. So let's just go ahead and do that. Sudo user mod -G stooges is the name of our group, and we want to add Larry. We use the command history here. We're going to add Mo. and we're going to add curly. Now if I look at the group file, we see that the group Stooges has 3 members. It has Larry, Moe, and Curly in it. And now if we had a directory called Stooges, maybe they're working on the script of their next big hit film or something. If there was a directory called Stooges and there were things in that and the group was Stooges, they would all have permission for that if it was set correctly. There is a group del as well, and it does just what you would expect it to do. Group del Stooges, and it's gone. In this video, we will discuss 3 useful commands. They are grep, sort, and cut. All of those commands are going to give us ways to deal with contents of files. Later, we'll be putting them together in interesting ways as well. This is just an introduction to those commands. We're going to work with a file called mlb40.csv. You can see I have it here. You'll have a copy in your working files. And what it is, it's a table of all the Major League Baseball players who have hit 40 or more home runs in a season. And it's the name of the player, how many home runs did they hit that season, what year was it, what team was it with, was it National League or American League. If they were with 2 teams that season, we have a slash between the 2 teams and potentially the 2 leagues. This is just to give us some data to work with, some variety of data, and that's not just some boring list of made up numbers. It actually does mean something. And if we further look at this list, you can see that it is sorted already by the number of home runs in the season. And we go from 73 with Barry Bonds all the way down to all the guys who have done 40. And then you can also see that within a particular number, they are sorted by their last name. The data is already in order. It's a comma-separated file. We're going to see what we can do with this file from the command line. The first tool that we are going to look at is called grep. Grep is a very sophisticated search tool. Be assured, we are just going to scratch the surface. There is a lot you can do with grep that's beyond the scope of what we're talking about here. So this is just an introduction to give us a little taste of it and be able to do some useful things with the data in the file. If we look at the man page for grep, it's spelled grep. It's spelled grep, and it tends to be used as a verb. So you grep for something. Grep that file for whatever you're looking for. That tends to be a usage that people use. It's also obviously a noun. It's the name of the command. Grep searches the named file or files or standard input if no files are named for lines containing a match to the given pattern. And the pattern is something called a regular expression. And we're not going to look into regular expressions here. The simplest regular expression is a string, and that's what we're going to be searching for. We're going to be searching for literal strings of letters and that kind of thing. You can see up there in the very first synopsis line that both options and the file or file names are optional. We're going to look at a simpler usage here. We're going to basically be doing the usage of grep pattern in a file. Let's look at some simple examples now. For instance, let's find all the Yankees who have hit, and I'm doing tab completion, 40 home runs or more in a season. On a lot of terminals, grep will actually highlight the match as well. It puts some little extra stuff in there, and that's kind of a special extra feature. It's not a default feature of grep, but it is kind of nice to be able to see what it is that you actually matched. I'm going to introduce another little handy command here, and that is clear. And watch what clear does. Clear clears the screen. I can still scroll back actually, but it gives me kind of a blank slate, and that'll be nice for separating the output of these commands. Let's grep for Ruth. Let's see how many times Babe Ruth did this. We expect his name to appear a lot, and it does. How about Hank Aaron? Grep Aaron. Not quite as many, but he's definitely up there as well. You kind of expect that from the guys who are the big all-time home run hitters. You get the idea. We could grep for various names that we expect to be on the list, and they're going to pop up with how many times they were on there. Let's do one more. Let's do Fielder, because we're going to look for Cecil Fielder. So we get Cecil Fielder and Prince Fielder, because grep doesn't care. It's just searching for the text we looked for. It didn't know that I was thinking Cecil Fielder when I typed Fielder. It found Fielder. And specifically, it found capital F-I-E-L-D-E-R. It is case sensitive. So if I had looked for Aaron in lowercase in that file, I get nothing. It had to be a capital A, lowercase A-R-O-N. You saw in the man page there were options to grep, and there are a bunch of different options. One that's pretty handy is a -i. It says, let's do a case-insensitive search. I would like to not make this case sensitive. Just find for me the letters AARON, uppercase or lowercase, I don't care. And then, of course, we get Hank Aaron. So as I said before, there is a lot more that grep can do, but the basic functionality, we can search for strings. The next command that we're going to look at is the command sort. And sort sorts things, but it can do some interesting things about the sorting. We've already seen the order of the file is by number of home runs in a season and then by last name. But if we do sort on the MLB, you will find Willie Stargell, Willie McCovey, and Willie Mays. It is sorting the line itself, the entire line in alphabetical order. And it's actually not alphabetical order, it is ASCII order that sort is going by. If we do a man of sort, we see, right, sorted concatenation of all files. You can give multiple files and they'll just all be together. But we sort, we give it some options for like how to sort and that kind of thing, and then the files we want. And as you can see, there are a lot of options. We're interested in two options. The -k is to sort by a specific field. And by default, those fields are determined by white space. So the other option we need is the -t, which tells us to use something other than white space as the field separator. We have commas as our separator. So let's say we wanted to sort by the year, the third field in the data. We could say sort -t, comma. Our fields are separated by comma, and then -k3. We want to sort based on the third field as defined by commas in mlb.csv. Looks pretty good. 2009, 10, 11, 12, 13, 14, and then Ken Griffey Jr., and then finally the header line that says year. What's going on here? Well, sort is very simplistic. It's just looking for commas. The CSV format says if a comma appears in one of the fields, we just surround it in quotes, and something interpreting CSVs needs to understand that the comma in Ken Griffey Jr. is not a field separator. It's just a comma in Ken Griffey Jr. Sort's not that sophisticated. That's just one of the little limitations of sort. If we really wanted to do this right, we probably would generate our data with some other field separator. Use a semicolon and then it wouldn't be a problem at all. If we look at, let's say, the 2012 lines, I'll highlight these here. Those lines, they're not sorted anymore by the number of home runs. They're sorted by the year, but then by what? Chicago, Detroit, Milwaukee, New York, Texas, Toronto. They're actually sorted by the entire line from that field on, because that's actually what we said. We said, start at field 3 through the rest of the line. There's a slight variation on this. If we want to sort just on field 3, we can do it this way. This syntax on the field specifier is a starting field, comma, ending field. So we could say sort on field 3, then field 4, or something like that, but we're specifying a chunk of the file to sort. So in this case, we're saying just field 3. So now when we look at the 2012 guys, we see they are not sorted by the rest of the line anymore. They were sorted just by that field name. What if we wanted to sort them by the year and then within a year by the number of home runs? We can do that. We can do a primary sort key and a secondary sort key is the terminology for that. If we say sort -t, comma, and -k 3, 3, that we're saying that's our primary key, and then -k 2, 2, the keys in order, we say search first by this field, then by this field. We could do that kind of as many times as we want, but 2 is enough in the MLB file. Now if I look at the 2012, we see that they are sorted by the number of home runs that they hit in 2012. Like with grep, there's a lot more that we can do with sort, and this is just, again, an introduction. Finally, we're going to take a look at the command cut. And the main thing that cut does is it pulls out portions of lines. Take a look again at the man page. Print selected parts of lines. And there's a lot of ways to select what part of the line. We can do it by fields. We can do it by characters. We can do everything but the things we said, various things. We're going to look again at a basic usage. There's a field separator character for cut as well. It's -d. With sort, it's -t. With cut, it's -d. And there are other commands that actually use a different argument for the field separator. These are like irregular verbs when you're learning a human language. You just have to learn them. You just have to learn with this command it's this, with this command it's this, with this command it's that. So with sort it's a T, with cut it's a D. We're telling cut my separator is a comma, and -F is for what field. So give me the first field as defined by a comma in that file. And we get everybody's name. If we go with, say, the fourth field, using my arrow keys to manipulate the previous line, with the fourth field we get the team names, etc. You get the idea. In this video, we will discuss how to combine commands to do some powerful things. We'll be using something called pipes and pipelines. First, we're going to define three terms: standard in, standard out, and standard error. Every program in Linux has these three channels you can think of as open. In the normal case, all of them are connected to the terminal. So standard in is going to be the input coming in from the terminal, what you type. Standard out and standard error both are going to print things to the terminal. Pipes give us a way to connect two programs. And the way we connect them when we make a pipe, the standard out of one command goes to the standard input of the other command. Let's take a look at an example. We'll use the mlb40.csv file that's in your working files directory. Use our grep command, grep for all the National League players in this file. Now when we do that, we get a big long list, more than one screen full. One way we can do that is we can use the terminal window feature and scroll back. But that's, strictly speaking, not a command line solution. We've relied on that because we haven't talked about anything else to this point. But it's not a command line solution. Pipes give us a way to do that. Let's do the same thing again. Grep National League in MLB40. And now we're going to do a pipe. That's the vertical bar character on, I think, most US keyboards, certainly on mine. It's the shift and backslash is where that character is on the far right-hand side of my keyboard. Whatever keyboard you're on, it's that vertical pipe character. We're going to hook it up to the less command. So what we're saying is the output of grep is going to go to the input of less. So you kind of get a visual of that. It's called a pipeline when we do this. Stuff is flowing through the pipeline is kind of the mental image to keep in mind with this. So now when I do it, I'm in the less command and I can do all the things I do in less. I can go forward, I can go back, I can quit, etc. We can do multiple things. We can do a grep of National League, and then let's sort that. And then let's send that result to less. So now we have sorted them. We're just sorting by the line. So Adam Dunn gets to go first, all the way down to Willie Stargell. So let's find the names of all the Yankee players who've hit 40 or more home runs. It's easy enough to do grep Yankees, and we get a list. Let's refine that list. Grep for Yankees. Now let's get just the names. So our field separator is a comma. We want field 1. And then when we get those names, we want to sort those names. Again, acknowledging it's going to sort by first name. And then let's put that to less. So now we're combining a grep, a cut, a sort, and less, all in one big pipeline. We see the end result in the less command. We see Alex Rodriguez twice, Babe Ruth a handful of times, Curtis Granderson, etc. Lou Gehrig, Mickey Mantle. If we just want to see a list of the players who've done that, it'd be nice to see them only once. There's actually a command that can do that. After the sort, we're going to send it to a command called unique, U-N-I-Q. What unique does is it suppresses consecutive lines that are identical. So those lines that said Babe Ruth, Babe Ruth, Babe Ruth, Babe Ruth, Babe Ruth, unique will only print one of those. It'll say the rest of this is redundant. So when we do that, we get a nice short list in one little quick Linux command. Here are all the New York Yankees who have hit 40 or more home runs in a season. I happen to think that's kind of cool that we can do that in a one-line command. This is a little overkill because there's actually an option to the sort command that also says to suppress duplicates. There's one good thing that we can do with the unique command. It has a flag. We can say -C, and then that says collapse all the unique lines that are together, but put a count ahead of the result. So now we see, we get our list. Each name is prefaced by a count of how many times they did it. Babe Ruth really stands out in this list, as you might expect him to. It would be nice if we sorted this by the number of home runs instead of by the first name, which was the sort. We can build on our command. We can do another sort. And I'm going to add a flag to sort this time. -n says we're sorting by number, not by string. So we want to be sure that 11 comes last in this list, not that it looks like a 1 followed by another 1, which would be the default for sort. So we do that, and we get the list from 1 to 11 of all the Yankees who have hit 40 home runs or more in a season. And there's another flag to sort just to show for completion. If we wanted the list to go the other way, we could add an R to reverse the order of the sort. Now we have a list kind of more like we would expect it to be. Here's all the Yankees who've hit 40 home runs in a season with the number of times that they have done it. All done with command line utilities. Let's look at one more example, and that's going to show us another option to grep. We've used grep to find things, but we can also use grep to exclude things. Let's say, how about all the non-Yankees? All the players who didn't play for the Yankees who have hit 40 or more home runs in a season. -v is an option to grep that says everything but this. So give me every line that doesn't say Yankees on it, is what I'm saying. Do that in my file. And then we're going to get the names. And then we're going to sort that. We're going to do the unique -c, and we're going to sort -n again. And this is going to be a longer list, so I'm going to do a less on it as well. So we're saying, show me all the lines that don't say Yankees, give me the player's name, sort that list by the player's name, then give me a count of the number of times each player has done it, then sort that list numerically, and then show it to me in less so that I can look at it a screen at a time. Of course, we have a lot of guys who've done it once, and we scroll down to the bottom of the list. Barry Bonds, Hank Aaron, and Harmon Killebrew are the top that weren't Yankees. There's one problem with this list. We see the quotation mark on Ken Griffey and not the junior because it's a CSV file, not truly comma every separated field. And Ken Griffey Jr. has a comma in his name, and CSV can deal with that. Cut, sort, those kinds of things cannot. But there is one problem. If we go back up here, we see right here, name occurs once. What in the world is name? Name is, if we look at the file itself, name is from that header field. So we really don't want name in our output. We can deal with that. We just add another command to our pipeline. I'm going to go right here, and we're going to grep -v name. So now we've got take everybody but Yankees, get rid of name, do the sort, get the count of occurrences, and sort that numerically. Now we have our proper data without name. Next time one of your friends asks you, hey, could you get me a list of all the Major League Baseball players who didn't play for the Yankees who hit 40 or more home runs in a season, and tell me how many times they did that. Now you have the tools to do that. This is all done with basic commands and pipes, and this is one of the very powerful concepts that the Linux command line has at its disposal. In this video, we will talk about input and output redirection. Like pipelines, we have ways to redirect the standard in and the standard out, and we also have a way to redirect standard error to files. For the examples in this video, we're going to be using the mlb40.csv file found in your working files directory. Let's talk about redirecting standard out first. Let's say we want to find all the names of the American League players who have hit 40 or more home runs in a season. And we want to look at their names. So we're going to say the field separator is a comma, and we want the first field. And we're going to sort that, and we're going to get a count. And then we're going to sort that list numerically and sort it from highest total to lowest total. We get a list that's a lot bigger than a screen. The only thing that fits on the screen are the one season guys. We could pipe it to less, but maybe we want to save that output. Maybe we want to hang on to that. So here's what we do. At the end of our line, we use a greater than character. I like to think of it as a funnel. So think of we're taking everything from this pipeline, and then we're going to funnel it out, and we'll just call it players.txt. So now we have a file. I can do less on players.txt. And here's all our players, Babe Ruth at the top of the list, a bunch of guys with 1 at the bottom of the list. And you notice when we ran the command, we didn't get the output. We took that output and we sent it to that file instead. We've redirected standard out. That's the term, and that's exactly what we're doing. Let's say I wanted to add the National League players to the list. So I go to this command, back up, do National League, and do the same thing. Where's Babe Ruth? Well, what happened here is that greater than symbol says, here's the actual logic behind what happens with the greater than. If the file does not exist, create it. If it does exist, truncate it, wipe out its contents, and then write all of your output to this file. So when we ran the National League, we wiped out all the data from the American League. What if I wanted to add? What if I wanted to have both in that file? Very simple. Let's go back up to the American League line. And if instead of a single greater than, we put 2, 2 means append. So append to the file. Now, if the file doesn't exist, it'll be created. Everything's cool, just like with the single greater than. But if the file has something in it, the 2 greater thans says append to the file. Stick it on the end of the file. So if we do that, and now we look at players.txt, we have our National League players, and then we start with the American League, starting with Babe Ruth, and they go in order. So let's talk about another kind of output redirection. And for this, I'm going to use a grep command in a way that will generate errors. Let me get rid of piazza.txt. That was from trying it before. I have this directory called stuff, and I just made the directory. It's an empty directory. And the reason I'm putting that directory there is so that I'll get an error from grep. And here's the error I will get. Let's say we want to grep for Mike Piazza. And I'm going to use an asterisk, often pronounced as star. I'm going to grep Piazza in star. And star just means all the files in the directory. So we're going to grep for Mike Piazza. And instead of specifying the file, we're going to say grep for him in everything. So grep for him in mlb40.csv, grep for him in players.txt, and grep for him in stuff. There's a reason I got rid of piazza.txt that we'll get to in a minute. When I do that, I get some results. Grep says, hey, you looked in more than one file, so I'm going to tell you what file I found it in. I found him twice in mlb40.csv. I found him once in players.txt, and I could not search stuff because stuff's a directory, not a file. That last line is actually an error from grep. It's not part of the output. And we can see that very easily if I do piazza.txt. I send the output to piazza.txt. When I do that, the error comes out to my screen and the output goes to piazza.txt. What if I want to also send the output to somewhere? I can do that. And we do that with a 2. The standard input, standard out, and standard error are 3 things that are always open anytime a Linux program is running. And each file our program has open gets a unique number. And those 3 always have the same numbers. And they are considered files in Linux. So standard in is always file 0. Standard out is always file 1. And standard error is always file 2. Any other files that get opened start at 3, 4, 5, etc. By default, the greater than and the double greater than, they assume we're talking about standard output. So we don't need to specify which file we're talking about sending to those files. By default, we're sending standard output. When we want to send something other than standard output, like standard error, we have to put the number in front of it. So that's what the 2 is doing there. 2 greater than piazza.error says send file descriptor 2, which is standard error, to this other file. Now when I do that, cat piazza.txt, it's got my output, piazza.error, and grep input file piazza.txt is also the output, is why I removed the file that was sitting there before we started. This grep is actually smart enough to know that you're looking for something in a file and then putting that output into that same file. In the good old days, when I was first learning this stuff, I had done something like this and I created an infinite loop. So it was finding the thing in the file and appending it to the file and finding it later where it had appended it in the file and appending it to the file. And I found out when someone else yelled at me because I had just used up the entire disk space on the system I was working on. So it's nice that it's a little more sophisticated now and it actually can detect that condition and just give you an error about it. But that's why I deleted the piazza.txt when we first started. I didn't want to confuse the issue. Now we have the output and the error in 2 different files, and these are completely independent things. I can grep piazza star, and I can say just do the error. So the standard out goes, the standard error is still there. It's actually a common enough thing to want to not see errors, to hide errors. And there's a special way to do that. Grep piazza, and we can send to a special file. That file is called dev null. The directory dev has a whole bunch of device files, different kinds of special things for Linux. All your disks are there, your network's there, memory's there, all kinds of things. But there's also this special file called dev-null. And what dev-null is a file, you can write stuff to it, and it essentially gets thrown away. Anytime you cat dev-null, it's completely empty. It's always empty no matter how much you write to it. The stuff you write to it is essentially just thrown away. It disappears. This direction right here, out to dev-null, is a standard way of saying, I don't want to see the output. Maybe you don't want to see any of the output. Maybe you don't want to see the errors. Maybe you only want to see the errors. You don't want to see the standard out, something like that. If you want to throw something away, send it to dev-null. That's a very common standard thing to do on Linux. There's one more output formula that we want to talk about, and that's redirecting both standard out and standard error to the same place. Let's just remove piazza.txt and piazza.error. So we have a clean directory. We still have our stuff so that we will get an error. We're going to grep piazza again. We're going to send the output to piazza.txt. And maybe I want to see the standard error as well. I want to see both my errors and my output in the same file. We use this little formula, 2 greater than ampersand 1. And what that says is send file descriptor 2, standard error, to the same place that file descriptor 1, standard out, is going, which in this case is piazza.txt. So we do that. We have a typo. We need to tell it where to search. By default, grep is going to look in standard input, so it was waiting for me to type something. So let's do it again with the proper argument, grep for piazza in all the files. We're going to send the output to piazza.txt, and we're going to send the standard error to the same place. Command comes right back, no output. If we look, there's piazza.txt. If we cat piazza.txt, we get the error and we get the output. This one does matter. The order does matter. Let's do it in the other order, and I'll show you what I mean. If we do it this way, now we see the errors. They didn't go to the file. Up here, we said grep piazza in all the files, put the standard out to piazza.txt, and put the standard error to the same place, piazza.txt. Basically, you read these left to right. We're going to look for piazza in all the files. We're going to send standard error to wherever standard out is going. That's the screen, that's the terminal. And then we're going to send standard out to piazza.txt. We actually told standard error to go to the screen, and then we told standard out to go to the file. So order does matter there. Generally speaking, if you just think of the 2 greater than ampersand 1 as going at the end of the line, you will be okay. The final thing to talk about is input redirection. A lot of commands will read from standard in or read from the keyboard, and we can tell them to do that from a file instead. So let's just do a quick example. This is a little less common. There are times when it's useful though. The example we would give will unfortunately not be all that useful, but let's grep for Babe Ruth and say, take your standard input from the mlb40.csv. Now that gives us the exact same results as if I hadn't used the file. But there's 2 very different things going on here. So let's talk about those. In this one, the standard one, we are telling the grep command to open the file mlb40.csv, then grep for Ruth in that file. In the second command, grep is only seeing grep for Babe Ruth. So grep is being told to use its standard input. That's the default input for grep if we don't specify a file. Well, how does it get that? That top one is absolutely functionally equivalent to this. That's effectively what's really happening. The contents of that file are coming in as standard input to the grep command, and then the grep command is looking for Ruth. You can redirect standard in, standard out, standard error. The output redirections definitely are things that you'll use more often, but there are times when you'd like for standard in to be coming from a file, and there's a way to do that as well. In this video, we are going to introduce and talk about something called shell metacharacters. Just generically, a metacharacter is a character that means something other than itself. First and simplest example that we'll look at is the asterisk. To the shell, an asterisk, usually pronounced star, just because that's easier to say, means 0 or more characters, and I don't care what they are. We're going to do this with the ls command, and we're going to do -d because we don't want to look in directories, we just want to see the names of them. If I'm in my home directory and I do ls-d star, I see all the things in my directory. This is basically what you see if I just typed ls-d. It's important to note the shell is who figures out what that star means, not the ls command. We can see that easily enough with a set -x to show us some debugging output. What is the shell actually doing? When I do ls-d star, here's the command that actually gets executed. ls -- color equals auto -d ch3 cpu hog.sh data database date desktop etc. That's just important to keep in mind. The shell is who does this interpretation. These characters are special characters to the shell and to the shell only. Now we can turn off the set -x by doing set +x. We've turned off the debugging output because we don't want to see that in general. We just want to make that point. We can combine meta characters with literals. So the meta characters don't have to be just star. We can say, for example, ls-d capital D star. And we see three things. We see desktop, documents, and downloads. So what we have said there is I want a D, and then I don't care. I don't care what you have after the D. Starts with a capital D, and then I don't care. Now we can refine that down. We can do multiple literal characters, D, E star, to get just desktop. The next character that we will talk about is the question mark. Now the question mark means one and only one character, and I don't care what it is. So it's like the star, except the star is 0 or more characters, and the question mark is one and only one character. Let's take a look at the difference of them. I have a few files here. I have a data directory, I have database, and I have date. So they all start with a lowercase d. In fact, they all start with DAT. So if I do DAT star, I see all three. But if I do DAT question mark, I see only the ones that have one more character after DAT. The final thing we're going to look at is something called a character class. And for that, I'm going to go over here to my user bin directory because there's a lot more things in it. If I do an ls, there's a lot of things in here. A character class is a way of saying we want a single character like the question mark, but we do care a little bit what character it is. If I do a ls-d m star, there's a whole bunch of things here that are m star. But if I say, actually I don't think I need the -d here because there's no directories. If I say m a-e-i-o-u. So what I have done is I have enclosed a-e-i-o-u in square brackets. So what I'm saying is I want an m. The second character immediately following the m can be an a, it can be an e, it can be an I, it can be an o, it can be a u. I don't care, but it has to be one of those. And then I don't care after that. I get a much smaller list. And sure enough, the m is followed by a vowel in every single one of those cases. We could say, I want the m to be followed by something from the first half of the alphabet. So we can say an explicit list of characters like we did with A, E, I, O, U, or we can say a range from A to L. And we get everything that's an M followed by something from the first half of the alphabet. Now, an interesting thing with character classes that we can do is we can negate them. And the negation character is a caret. If I put it anywhere else, it means the caret character. But if it's the very first thing, it means not. Give me M followed by a character that's not A through L. We get M followed by things in the second half of the alphabet. And we can go back to our vowel example. This is maybe a little more interesting. A, E, I, O, U and star. And we get everything that's an M followed by a consonant. One interesting question that you may be thinking at this point, what if I really want a bracket? What if I really want an asterisk? In general, you're not going to run into that in the shell because those are not things that we would normally name files or whatever. The simple answer is there are two things you could do. You could enclose it in single quotes. That's probably the easiest. If I use single quotes, the apostrophe character on the keyboard, if I enclose it in that, I'm telling the shell, do not interpret this. And when I do that, I am searching for the literal string m square bracket caret a-e-i-o-u square bracket star. And there is no such file or directory. The other thing you can do is you can put a backslash in front of a particular character to mean literally the character, but generally it's easier if you want the shell not to interpret what you're saying, just put single quotes around it. In this video, we'll be working on developing a better understanding of shell meta characters. And we're just going to work through a bunch of examples. To do these examples, we're going to create a directory that is just going to be for this. We need to make it first, make a directory called meta. Let's go there. It's an empty directory, of course, because we just made it. If you want to follow along with this, we're going to run this command. We're going to create a bunch of files. and there's a specific set of files that I want you to create. This is going to be kind of long, but let's do exactly this. They're all English words. Abet, able, ably, abut, abacus, aboard, abroad, absorb, bail, bait, band, bang, bakery, banked, banker, and bizarre. The reason for that list, that is a list of 16 different English words, basically. We've made them as files so that we can do them with the ls command. 8 of them start with A, 8 of them start with B, and there's other similarities in them that you can easily see. Let's just walk through a few scenarios on how we might match sets of these names. So for instance, how would we list all the files whose names end with R? We want ls, and we don't care what's happening in the name except that it has to end with R. We do that, we get the things that end with R. How about all files that have an S in the name? We don't care what's in front of the S, we care that there's an S, and we don't care what's after the S. That's essentially what we need to say. So those are anything that has an S anywhere in the name. And you'll notice that we did match abacus, which ends with S. When we talked about the meta characters, we said that the star could match 0 characters. It is 0 or more characters. Well, in the case of abacus, we matched ABACU with the first star. We found an S, and then we matched 0 characters with the trailing star. So that's a nice illustration of the fact that we can match 0 characters. How about everything that starts with B, A, and then a vowel? We have a few that start with BA, but a smaller set that start with BA and a vowel. We just put AEIOU in a character class, and then we do have to say star after that. If we don't say star after that, we are looking for things with a 3-letter name that's B, A, and then a vowel. But if we put a star, we say after the first 3 characters, I really don't care what they are. How about any file that has 2 consecutive vowels in it? Think about that one for a second. How would you say 2 consecutive vowels? Somewhere in the name. Somewhere in the name, so that means I don't care necessarily how it starts. I care that there's a vowel, and then I want another vowel, and I want them to be right next to each other, and then I don't care. And I get all the things that have 2 vowels right next to each other. How about things with 4 letters in the name? Is there an easy way to say things with a 4-letter name? There is. I don't care what the character 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 is. I just care that there's 4. How about things that have an L or an N as the 3rd letter in the name? Once you wrap your head around this one, I think you've got shell meta characters totally understood. An L or an N as the 3rd letter in the name. Now we could say L or N, and we get a lot right there. Bail, the L is the 4th letter in the name. We've said I don't care where it is. So here's what we do. LS. I don't care what the first character is. I don't care what the second character is. The 3rd character has to be an L or an N, and I don't care what happens after that. There we go. All the words in that list that have an L or an N as the 3rd letter. Spend some time with these. Maybe try to come up with some of your own. Say, oh, what are the words? Whatever. Make up your own thing and experiment with it. Get the meta character formula that will match that criterion. If you understand these examples, maybe come up with a couple of your own. I think you will have a very good understanding of the shell meta characters. In this video, we will be talking about customizing commands with something called aliases. So far in this course, we've been using default settings that our system gave us and default versions of commands. But there's actually a lot that you can do within the shell to customize things to your own preferences. And the first thing we're going to look at regarding that is aliases. As you might guess from the name, an alias is something you type in place of something else. Let's start with just the command alias. If I give the command alias with no arguments, it lists the aliases that are already defined. And these are the default ones on Linux Mint. We have 3 aliases defined, and they're defined in the format of the alias command itself. So that command can be typed just like that to set an alias. You'll notice that 2 of the commands that we have used a lot in this course, grep and ls, are actually both aliases. So in reality, every time that I have typed ls or grep in this course, the command I've actually been running is grep -- color equals auto or ls -- color equals auto. Just as an interesting thing, you notice that one has color with the British spelling and one has color with the American spelling, just done by different people at different times. And unfortunately, that's just something you would have to know or look up in the man page which spelling it uses. Well, let's prove that that's what happens when I type ls. We'll do a set -x so that bash is going to show us what command we're running before we run it. After bash has interpreted the command line, what is actually being executed. And if I do ls, you see, indeed, I did run ls -- color equals auto. If we do ls videos, which I think is an empty directory, but just to give an argument, the command actually being run is ls -- color equals auto videos. If I type ls, I am using the alias. But if I type the full path to ls, this is the full path that resides in the bin directory. If I do that, then the command I run is /bin/ls. So an alias is an exact match for the first thing on the command line, where thing is defined by whitespace. From the start of the command up to the first whitespace is the alias. There's no substring matches. There's no funny stuff of any kind. And we can prove that with the echo command. The echo command is like a print. It just prints out whatever its argument is. Echo ls. In this case, again, ls is an alias, but it is now the second thing on the line. So we just echo out the letters L followed by S. So in short, an alias is a way to create a shorthand version of a command that you frequently run. For instance, obviously the decision was made. Hey, it's handy to have the colors turned on. You see the difference. If I use the colors, I see directories are in blue and executables are in green, and I think there's a couple of other colors that are used in this. But if I don't use the colors, the second example of the command, then everything's just my normal text color. So it can be kind of handy. It helps me identify things by what they are. But typing out ls -- color equals auto every time is kind of a pain. So let's make an alias. The syntax for an alias is exactly what you see at the top of the screen there. Let's make a new alias. Let's say we want to make a recursive listing alias. So we're going to alias, let's do lsr equals. It's important that there's no spaces here. So lsr is going to be my alias, and it is going to be ls -lr -- color equals auto. And we put it all in quotes because we want the alias to be one thing. And the quotes tell the shell this is one thing. So now if I do that, let's turn off the echoing. We turn it on with set -x. We turn it off with set +x. Let's do lsr. You see, we get a recursive listing. Let me scroll this back a little bit. Recursive listing with color in the long format. Exactly what I said for the alias to be. Now, one thing to be careful of. If an alias masks another command, the alias is what will get used, just like we've done here. The alias for ls is used in place of the normal command for ls. The alias for grep is used in place of the normal value for grep. Let's abuse that. Alias ps equals ls. Now, every time I type ps, I'm actually doing the ls command. And in fact, I'm actually doing the alias for the ls command. So we have two levels of aliasing going on here. ps actually means ls, which actually means ls -- color equals auto. If I did this, I'm not running the ps command like I thought I was anymore. Now I could still get to it with its full path like we saw earlier with ls. But what if that was a mistake? I didn't really want to do it that way. Removing an alias is even easier than defining one. The command is unalias. Unalias ps. And now, if I say ps, I get the ps command. It's back to its old self. You can go to town with this, or you can do one or two things. It's up to you. You can make aliases for fun, for convenience, a little bit of both. But that's how you make and remove aliases, and that concludes this video. In this video, we will be talking about something called the path and how to customize it. We have been taking for granted all this time that when we type a command, bash knows how to find it. Bash knows where it is, knows what to do. There's a command type that we can look at. What it's saying is, when I type something, where does bash find that command? Type PS, for example, is asking bash, hey, when I say PS, where are you looking? And bash tells me it's in /bin/ps. In fact, it is hashed, and we'll talk about what that means in a little bit. Now, the type command is pretty smart. It knows about all the places that bash knows to find a command. For instance, if I say type ls, it says, hey, that's aliased. It's actually an alias for ls ---- color equals auto. Type also knows the alias command is actually built into bash. There's not a command that gets run or an external program that gets executed. That command named alias is built into bash itself. It's something bash knows how to do. It doesn't go out and execute another command to run that. We have external commands. We have aliases, which are internal to bash, and then might be external commands, but there's another layer there that we are not seeing. And then we have internal built-in commands. So for things in that first category that are commands out there on the system, how does bash know where to look? How does it know that PS is in the bin directory? To answer that question, first we have to talk about something called environment variables. Environment variables set the environment for the shell. You can see there's a whole bunch of them. There's things like the home directory. There's things that define my terminal. There's things that say what directory I'm currently in, what my username is, all kinds of stuff. This top gibberish here is what my terminal is capable of, things like that. You can see it about middle of the screen right here. There's this one path equals. And that path is telling bash, look in these directories for commands. That's really all it means. Let's go here and let's make that stand out a little more. Echo $path is the way to show what it is set to. It is customary to put environment variable names in all capitals. It's not necessary. There's nothing specific about that. It's just a nice way to distinguish them from other variables. What's special about environment variables, really the only thing that's special about them, is when I fire other shells and when I fire off other commands, those variables all get passed, which is why you can kind of think of them as being like global variables. So we have the path, and it's a set of directories separated by colons, is the syntax of the path. In my case, when bash is looking for the ps command, here's what actually happens. Bash looks and says, is there a user local sbin ps? Is there a user local bin ps? Is there a user sbin ps? Is there a user bin ps? Is there an sbin ps? Is there a bin ps? We found it. It's exactly that. It is a first match in this list going from left to right is what happens. If I put a PS in user local bin, for example, that is the command that will get executed, not the one in /bin. Back to when I say type PS, it says it's hashed. So what the shell does, the first time it has to look, first time I run the command PS, it actually has to look, and it does exactly that algorithm I just talked about. It looks in this directory, it looks in this directory, it looks in this directory, it'll go through the whole list. And if I say, fiddle, I get command not found. So that went through the entire list and did not find a command called fiddle. Then bash tells me, I don't know what you're talking about. There's no command called fiddle. In the case of PS, it stops when it finds PS. So it stops as soon as it finds one. So if one's in a later directory, you'll never execute that one unless you specify the path to it. The hashed means that bash has remembered that answer. We can prove this. Let's start up a new bash. What we've done is we've just created another instance of bash. And if I say type PS, it finds it via the path. It says, hey, this is in /bin/ps. Then if I run the command ps and type ps again, now it says it's hashed. Bash remembers because I've asked it to do it once. It says, hey, if you did it once, you might want to do it again. I'm just going to remember that location. And the hash is basically the algorithm that's being used to remember that. It's called a hashing algorithm. Not something you need to worry about. Hashed just means remembered is what you can think of it as. We can type exit to get out of that shell. It's easy to extend the path. What if I wanted to add a directory? One common thing to do is to put a bin directory under your own home directory, like /home/jeff/bin. And if I wanted to do that, and I wanted those commands to be available to me to type without a full path, what would I do? Here's the syntax. Path equals, notice there's no $sign there, and there's no spaces, and both of those things are important. No $signs, no spaces. Now I could specify the whole path just like it's given and add to it. But I can do a little shorthand. I can say $path:/home/jeff/bin and close the quote. Now, a few things that are important about this. When I say path equals, I'm basically doing the assignment to what path is. When I say $path, I'm saying, just like when I said echo $path, I'm saying that whole string, /usr, /local, /sbin, etc. $path is going to get replaced with that value. And then add a colon to that value and put /home/jeff/bin. Now the double quotes there matter. Quotes tell the shell to gather things together as one argument. That's essentially what the quotes do. And you can use single quotes or double quotes. Double quotes are the ones that we would call a quotation mark. Single quotes are the ones that we would normally call an apostrophe. The difference is single quotes means a literal string. Don't interpret anything inside it. We've talked about the bash or any shell interprets the line and then executes the line. When you close something in single quotes, you are saying this is a literal string. Do not do any interpretation of what's in between these quotes. When you use double quotes, you say, feel free to interpret what's in between these quotes. So we need to make sure it's double quotes, no spaces, and then we can do that. And then if I echo $path, you see I have the string that I used to have, and then a colon and /home/jeff/bin. And that's really all there is to it. It is best to use this syntax. Like I said, you could specifically set the path to something, but there's a default that's set by the system. And so anything you do, you should just add to the path. Don't try to mess with it or replace it. Just add to it like we did here, and that will do what you want to do most of the time. In this video, we're going to talk about customizing your prompt. Yes, that prompt we've been seeing all this time, the Jeff at Linux in the directory, that is completely customizable. It's defined in an environment variable, and it's something that we can set. The variable is called PS1. You can see there's a lot of gibberish in there, and we'll talk about what that gibberish means in a minute. It's a set of instructions, basically, for what to set my prompt to. That gibberish there is defining the colors, it's defining use my username, use my host name, use my current directory, things like that. Let's back up and let's do a really simple example. In the old days of the Bourne shell and the Corn shell, the prompt was a simple $sign. We can just set the prompt to a string, $sign and a space. Notice I used the single quotes. Single quotes tell the shell, don't attempt to interpret anything in here. $sign happens to be special to the shell. For this prompt, it's a good idea to put this in single quotes because you may not want things to be interpreted by the shell before it sets the value of the prompt. And it's good to have a space after it. If I said PS1 equals just a $sign, I can type commands, but it looks kind of cluttered there. So if I say PS1 equals $sign space, looks a little better. It's good to have a space after your prompt. So my prompt is a single $sign. Commands work, ls, ps. There's nothing special about the prompt other than it's what tells me that bash is ready for me to type a command. You can put anything you want as your prompt. Here, I'll do double quotes because there's nothing to go here. Speakmaster. You can set your prompt to something like that. When you first learn you can do prompts, you tend to do stuff like this. And it's really, really funny. You might even think it's the most hilarious thing ever. Take my word for it. After a couple days, or if you're easily amused, maybe a month or two, this will get less funny and you'll want to actually do useful things with your prompt. But it's good to have fun sometimes too. Now, if I start a new shell, I've just set the prompt for this shell. If I start a new one, I go back to the default definition of the prompt. The things that actually define the prompt are this \u is my username, this \h is my host name, and this \w is my working directory. Everything else there is for another purpose. And all this stuff is defined in the man page for bash. If you haven't looked at it yet, the man page for bash is big. Now there's a section here on prompting. Search down for that. So here's all the things that can be put into your prompt. The host name, new line carriage return, the name of the shell, the current working directory, the history number of this command. This one here is kind of interesting, \$. In the old days, it was customary for users to have a default prompt of a $sign and for root to have a prompt of a £sign or a hash sign. \$$ actually sets the prompt to be either one of those. If you're root, you get the £sign, otherwise you get the $sign. all kinds of stuff can be set. Let's go with just \u at \h \w. You see there's the $$ there. We're just going to go with a $. I get functionally the same thing, but just without the color. That's what those little numbers and brackets and things are. Those are defining colors. Let's make kind of a crazy over-the-top prompt, just using a bunch of those things. These are all pulled from the man page. You can go back, look at the man page, and see where all these things came from. \s \V with \j jobs \n running at \t \d \n \w \n ready, set, go with a space. I have set a multi-line prompt. Tells me that I'm running bash, what version of bash, how many jobs that bash is currently running, what time it is, what date it is, what directory I am in, ready, set, go. It's still a prompt. I can run ls. So you can get pretty ridiculous with a prompt. Let's set the color as well. All those little escape sequences. These are basically instructions to the terminal to do a color, and they're a terminal specific thing. We'll kind of steal from the stuff up top, and let's do a \bracket \e, which is the same as the \033. This is something to Google for if you want to look up how to do the colors, because I do not have these things memorized, and nor will you. \s \v with \j jobs \n running at \t \d \n \w \n ready, set, go. And literally what I did to prepare this was I did some Googling on colors, found some pages where people listed out tables of what the different colors were, and then I experimented with some colors. And this is what I picked. Now there's an important one to add at the end. If I leave it at this, I will set the color to that when I set the prompt, and everything that happens after that will also be that color. So the last thing we want to do is we want to unset the color, and that's a 00M. So that 00M that you see on the default prompt, and now that I've put in here, that says go back to default colors. So if I do that, I've now set kind of a yellow prompt. My commands come out as the default color for this shell, which is white. Now I can kind of visually separate my prompt from the rest of what's going on. Feel free to play around with this. Anything you do is specific only to this shell. If you remember, we started a shell. So when I exit, everything goes back to what I had before. So this is just specific to that shell. You're not going to break anything. You're not going to cause any harm or anything by experimenting with your prompt. Now the corollary to the fact that it's nice, it goes away, you're not going to hurt anything, is that it goes away. So if you find something you really like, make sure you save that somewhere, write it down so that you can do it again. We'll talk about how to make that your default. But for now, just experiment, write down things you like, save them somewhere in a file or something like that. If you want to play with colors, do some Googling, find references online. In this video, we will talk about making your shell customizations permanent. And specifically, we will talk about the aliases, the path, and the prompt. How to make them persist across sessions. So far, the customizations that we've made have only been in the shell where we ran the commands. And it'd be nice if we have something that we always want to be the case when we open a window with a bash. Maybe there's a prompt we always want. Maybe there's aliases we always want. That kind of thing. It'd be nice to be able to make that permanent. First, we need to talk about how the shell is configured when it starts up. There are two possibilities to talk about, and they depend on whether the shell is a login shell or a non-login shell. Here's how that works. Your shell is a login shell if it's the shell you log in with. That maybe sounds fairly obvious. What that basically means is if you logged in at a text console or you did a remote login like via SSH, then it's a login shell. Anything else, including the terminals that we start from the GUI, is going to be in the non-login category, interactive non-login, and that's to distinguish it from a script that's running, because that has a different setting. So if it's a login shell, bash is going to look in the directory etc profile, system-wide default list of things to run for all login shells. Then it will look in your home directory, and it will look for one of three files. And this is a first match. So if it finds a .bash underscore profile, it's going to run that. If not, it will look for a .bash underscore login. If it finds that, it will run that. And if not, it will look for a .profile. And if it finds that, it will run that. And it's just the first one of those. It won't run multiple ones. Now, in the case of the non-login shell, which is the one that we're doing with the GUI, there's a system file called etc bash.bashrc. And that sets the default. That's actually where the prompt that we've seen and the aliases that we've seen and the path that we have seen, those are all set in that file. And then we can do in our home directory a .bashrc, and that can be any extra settings or any changes to the system settings that we would like to do. We are dealing with the non-login shell, and basically what this means is that we're going to create a file called .bashrc in our home directory, and we're going to put our customizations in there. I'm going to use the VI editor to create and edit this file, but you can use another editor like Pico or Nano, or even a GUI editor like gedit. This isn't about how you edit the file. This is about what's in the file. What's in the file is what matters, not how we got there. I'm going to vi.bashrc, and currently it does not exist in my home directory. That's the default for Ubuntu-based systems. I don't have a bashrc, so I'm going to create a new one. So I created, it says down here, it's a new file. It's completely empty. Let's start with the prompt, because that's kind of the most visible change. It's easy to know that it's working. The prompt we're going to do is \e bracket 01:32m \bracket \w space \bracket \e 01:34m \square \t $, and then we'll undo the colors 00m \square and close the quote. And then I'm going to save this file. Now when I start a new bash, I get a new prompt. If you are following there, it's got the current working directory and the current time. Just maybe something that I want to have as my window. Now we can go back to our first shell. That hasn't been run in the first shell, so I don't have that prompt yet. Let's do a change and let's add a path. What's actually going on in this file? This is a file that contains a list of commands. It's actually a script. It's actually a program that can get executed. At the first level, you can think of it as a list of commands that should be run every time I open a new terminal window. That's essentially what we're doing here. We type these just like we would type the command. So path equals $path. I need to make sure I use double quotes, /home/jeff/bin. And let's go ahead and do an alias as well. lsr equals ls minus lr -- color equals auto. I'll save that. Now when I start a new bash, I get the different prompt. If I check the aliases, I have my new alias. And if I check my path, I have my home Jeff bin included in the path. So there's the idea. At the first level, think of it as a list of commands that you want to make sure are run every time you open a new terminal window. In this video, we're going to talk about the VI text editor, and we'll talk about why learning VI is important. So far in this course, we've sort of waved our hands when it comes to editing any text files and just said use whatever works. There are options like gedit. Gedit does a great job. It works in the GUI. It's very similar to Notepad or on Windows or TextEdit on a Mac, and it gets the job done, but it's not a command line answer. It works in the GUI. It's not a command line program. It's time. We're ready for it now to do our editing entirely within the terminal window. And for that, we're going to use VI. There are other command line editors. Major ones include Emacs, Pico, and Nano, but VI is the one to learn. Why is that? First and foremost, VI is universal. If it's a system that has a terminal, has bash, and calls itself anything remotely resembling Unix or Linux, it's going to have VI. You can just count on that. In fact, VI is part of the POSIX standard, which is basically an international standard for systems that are like Unix. So anything that's going to meet the POSIX standard has to have VI as part of the system. So if you log into a Linux system, you can guarantee that VI is installed, whereas other programs may or may not be installed depending on options that were used. The second thing is VI is a very lightweight program. but it's also very powerful. Like Pico and Nano that we mentioned are very lightweight and very straightforward to use, but they're not nearly as powerful as VI. Emacs is very powerful, but it has never been accused of being lightweight. So VI is kind of this nice sweet spot of being really powerful and really lightweight. A quick demo of what VI can do. I'm going to load up the entire text of the play Macbeth by William Shakespeare. And I just want you to watch this. I'm going to hit return now. And before I finish saying now, the program has loaded, the text of Macbeth has loaded, and VI is waiting for me to do something. There's just kind of an indicator. Computers are fast these days, but still, VI is lightweight. Let's see something like finding some text. Find the word dagger. There's a famous soliloquy where Macbeth hallucinates about a dagger. I can just type a slash and dagger, and there's a mention of it, and I can go to the next one, and there's Macbeth talking about the dagger, just like that. In fact, we can have a little fun with this. I'm going to replace all occurrences of dagger with kazoo. It says I did 10 substitutions on 10 lines. I can go back up to the top. I can search for kazoo. And there we go. Is this a kazoo which I see before me, the handle toward my hand? Come, let me clutch thee. Kind of silly, but kind of fun. I mentioned Emacs. There's a long-standing debate. If you search VI versus Emacs online, you will find this is an argument that's been going on for 40 years. Which one do I use, VI or Emacs? VI or Emacs? Emacs might not be quite 40 years old, but there's nothing wrong with Emacs. It's extremely powerful, but it is bigger. It's a little less likely to be installed on a system, and it's in a lot of ways a lot more complex. I'm going to advocate and tell you up front, VI is the one to use for now. Feel free to take a look at Emacs, and then you can decide where you want to land on that war. But we're going to talk about VI in this course. In this video, we're going to cover the basics of editing in VI. In reality, although I say the basics, this is really the minimum of what you need to be able to do things. This is enough for you to create and edit files using VI. Anything else you might learn in VI is there for convenience, efficiency, flexibility in doing things, whatnot. This video will contain enough that you can create, edit, save files in VI. So first, let's start a new file. I'm just going to call it Scratch because it really doesn't matter what it is. So VI Scratch. If we give a file name as an argument to VI, there's two possibilities. If the file exists, VI will open it and be ready for editing that file. If the file does not exist, which is the case here, VI will create that file for us and we'll be ready to go. When I hit return, VI opens up and it tells me that I'm editing the file Scratch, and that's a new file. An important thing to know about VI is that VI is modal, M-O-D-A-L, modal, meaning it has modes. What we mean by that is there are various modes you can be in, and depending on the mode you're in, different things will mean different things. Behavior will be different when you type the same thing depending on what mode you are in. That can be a little confusing, but you actually, I think, can get used to it really quickly. When we open VI, we are in what's called command mode. What that means is that anything we type is going to be interpreted as a command to VI rather than something that's going into our file, rather than text that belongs in our file. You see a bunch of tildes running down the side of my window here. Those are not in the file. Those are just a visual indicator that there's nothing there. They're sort of like a this page intentionally left blank. The tildes mean this line does not exist. They're just showing me, because it's laying out in my terminal window, what the file looks like. If the file is shorter than the terminal window, the tildes tell me, and that's the end of the file. So let's learn our first command in VI. A lowercase I. I'm going to type, you're not going to see it because I'm in command mode. I'm typing a command, an instruction to VI. I'm going to type a lowercase I, and that's going to put VI into insert mode. There, I did it. Like I said, you can't see anything. Now what we type is going to be text going into the file. If I type another lowercase I, it shows up because now I'm in insert mode. So we're going to put a few lines in the file. Here is and that's a deliberate typo. We're going to deal with that later. Here is another line and a third line, exclamation point, because we're excited about 3 lines. So we just put a few lines of text in our file. You notice that we now have 3 lines of text and then the rest is tildes to tell us that this file is only 3 lines long. Now, the next most important command to learn after how to go to insert mode is how to go to command mode. To do that, we type escape. Hit the escape key. I'm now in command mode again. When you're working in VI, you're doing a lot of that. You're toggling back and forth between insert mode and command mode. I and escape are kind of the two most important things to know about VI. One of the cool things about VI is that it's designed so you never need to move your hands. You pretty much don't need to move your hands from normal typing position, from the home row. And I'm in command mode, and I can move around in the file, and you can't see it, but my fingers are on H, J, K, and L on my keyboard. And that's enough to move around. Those 4 characters move around. We'll get into that. And it may seem weird at first to use letter characters to move around, but it's actually really nice because you hit escape. Now your keys right there under your fingers already are your navigation keys. So I'm going to move up to the typo. And the next thing I'm going to do is I'm going to type an X. X means delete a character, and specifically delete the character at the cursor. We can do it as many times as we want. We just need 1 here to remove the S. So I typed X, and now my S has been deleted. I'm going to type I to go back to insert mode, and then I'm going to type an X. There's a really good example of the same thing meaning something different in each of the modes. When I was in command mode, X meant delete the character at the cursor. When I was in insert mode, X meant type an X. Let's escape again, go back to command mode, and you'll probably get in the habit. I just did it again. Unfortunately, you can't see it in a screencast, but I just hit escape a couple of times. And it's kind of a habitual thing that I think most people who use VI develop. You just get in the habit of hitting escape to make sure that you're in command mode. So like I said, with X, we can delete characters, and I can hit it several times. I'm just hitting X over and over and over again. I can delete all the characters in the line. You notice I did not delete the line. Here's again where the tildes are handy. I have a blank line now. Another command that's really handy to know is dd. 2 Ds typed in a row, lowercase d's. So if I type dd, that line has been deleted. I can type it again and delete another line. Another really handy command. It doesn't matter if the line's empty, if the line has stuff on it, dd will delete the line. Now the next thing to know is how to save a file. From the command mode, you type a colon and a W. You notice the colon, and there's a whole set of commands that can come after colon. The colon causes things to echo at the bottom of the screen. I can type :W. It says I've created a new file that contains 1 line and 24 characters. We can also give a file name as an argument to do effectively a save as. I can say :W space and a file name, and I could save it as something different. The final thing to know is :Q. Q is for quit. There we go. We have created a file. It's called Scratch. We can check the contents of that file, and it says here is a line of text. VI is a complex program with a lot to learn, but it's also fairly simple to learn enough just to get by. Insert, command mode, move around, change some things, delete, insert, and save. That's enough to get you by and really be able to do what you need to do in VI. In this video, we're going to review the basic editing commands in VI. We're going to add to that. We're going to add some more advanced editing. As we go along the way, we're going to document the commands we're talking about. So at the end of this, you'll have a text file that's basically a VI quick reference document. I think it's going to be helpful to create the document using VI and learning the commands that we're documenting as we document them. We're going to create a new file. I'm going to call mine VI quickgref.txt. You can call it whatever you want. New file. And let's insert. Let's document that as our first command. I is for insert. Let's also add escape for enter command mode. You remember those are kind of the 2 most important things that we do. We insert, we enter command mode, we go back and forth between the 2 modes. Now let's do a blank line, and let's make a section called navigation. Let's document our 4 primary navigation commands. We got H, and I'm just hitting a tab between these. So I'm typing H and then a tab, and then this is move 1 space left, and then a J, move 1 line down, and a K is move 1 line up, and L is move 1 space. Let's make an editing section, and we talked about X. X is delete character at cursor. We also talked about dd, which is delete line. And we'll make one more section on saving and quitting. And in there, we talked about the :w is save file, :w something like ABC, save as ABC, :q is quit, :wq is save and quit. And there's one we didn't talk about, and that is one you'll see a lot of people talk about, especially in VI tutorials. They'll say use ZZ, and that is also save and quit. And it's just another synonym for it. It's actually something I don't ever use. I learned the :wq, and that's just what I use for saving and quitting. Either one, it really doesn't matter. There's sort of what we talked about before with our basic commands. Let's go ahead and save that file. We'll do the :w and save that file. Let's go up to editing because there's a handy one that we haven't talked about. And that is if I go up to this line and I type an O, you notice what that did. Lowercase o opens a new line below the cursor. And it actually has a buddy, a capital O, opens a new line above the cursor. Now we've kind of fleshed that out a little bit more. Let's use that. We're going to go up here to navigation. We're going to add a few navigation commands. O to open a new line. Capital G is go to last line. 1G, go to first line. And I'm going to put etc. here. I'll explain why in a minute. :7 is go to the 7th line. And I'm going to put an etc. on that one as well. So let's see what those are talking about. Hit escape again to go back to command mode. Let's talk about each one of those in turn. Capital G goes to the last line. I jump right there. 1G goes to the first line. 2G goes to the second line. 7G goes to the 7th line. Similarly, if I do a :9, I go to the 9th line. :1, and I go to the first line. So those two are kind of interchangeable. Number, capital G, or :number return. Either one of those will take you to a specific line in the file. Very handy. We'll talk about two more here under navigation. If I do a / and then some text, it will go to the occurrence of that text. And an N will repeat the last search. Let's see that one in action. Let me go to the top of the file, and I'll type /go and hit return. And then next. So you see I just go to each occurrence of the word go. It's a case-sensitive search, like a lot of things are in Unix. And you notice one more thing. When I wrap around the file, it will wrap around and go back to the beginning of the file. And it warns me when it does that. So that's kind of handy. It tells me, essentially, even though it's wrapping around, right there it's telling me you've seen all the occurrences of go that there are to see in this file. 3 more navigations to talk about, and then we will finish out navigation. One that's kind of handy, W will go to the next word. Word is not quite the English definition of word, and we'll see that in a second here. 0 is go to beginning of line, and $sign is go to end of line. So let's see those in action. Let's go up here, and if I type W, 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 notice the punctuation characters are counting as words. So when I get to here, the parenthesis is a word, the etc is a word, and the parenthesis is a word. The / is a word, and then text is a word. So that's where I was saying it's not quite words like you think about them in English, but it's a handy way to move to a specific spot in a line. If I type a 0, it goes to the beginning of the line. If I type a $sign, I go to the end of the line. And unfortunately, in a screencast, you can't see the thing I'm typing because it isn't echoing on the screen. So I'm trying to make sure I say what it is that I'm typing as I type it. There's a few handy things to talk about here under editing. Let's do this. At the very beginning, we put the insert command. But it's not really like a top of the list command because it's really an editing command. So I'm going to do a DD. We talked about DD is delete the line, but it's really not delete the line. I can come down here and I can type a lowercase p. What happens when I do DD is that line goes into a clipboard, just like when you do a cut on a Windows or a Mac system. I can then paste that line. So a lowercase p will paste after the cursor. So if I've done a whole line, it will paste below the line. If I've done less than a line, it'll go after the cursor. So that's why I say after the cursor. And like with the O, a capital is paste before. So those two kind of have a corollary between each other. Let's talk about a few more editing commands. We've talked about dd for delete line, but there's a few more quantities of things we can delete. If I say delete dw, that means delete word. That W is exactly the same as under the navigation. Delete and then a navigation is actually a general principle within VI. I can say D and some navigation and I'll delete that much. I can say D capital G and delete from the current line to the end of the file, for example. There's also a change. I can say CW for change word. We'll take a look at an example of this just so you can see what I'm talking about. If I just type some gibberish, W will navigate these as words. If I go to this one, for example, and I say DW, that word gets deleted. If I say CW, let me do that again. CW, you notice the very last thing I'm going to be changing changes into a $sign. And I can type some stuff, and I can hit escape to go back to command mode, and I've changed everything up to that word. Get rid of that. Similarly, DT will delete to a character, and CT will change to a character. So let's see that in action. Type some gibberish, and let's go right here, and I'm going to say DTJ. And everything from my cursor up to the J gets deleted. Similarly, if I say CTD, you notice I get a $sign just before the D, and 1, 2, 3, 4, 5. I typed 5 twice. You get the idea. I can say DL, and I'm deleting one character, for example. Any of those movement commands can actually come after the D, but the ones you'll use are DD, DW, DT, CW, CT. Get rid of that again. We'll go right here. There are two more that are pretty handy. U will undo the last change, and a dot will repeat the last change. The dot is very handy. Let's say you wanted to add something on every line. You can do the add once, go to the next line, hit dot, do the add again. Go to the next line, hit dot. It's a very handy thing to use. We talked about insert. There's a corollary to insert, which is append. If I'm here on the N and I type insert X, I get an X in front of the N. Type U to undo. If I type A and then an X, I append an X. I put the X after the N. You can pick U for undo again. You can do either one of those. You can do the insert, you can do the append, just depending on where you are on the cursor and where you want the thing to go. And then there are two more that are handy with that. Like we've seen with a lot of the other commands, there's a lowercase version of the command and then an uppercase version of the command that does something a little bit different. An uppercase I will insert at the beginning of the line. And maybe you can guess what a capital A will do. It will append to the end of the line. We've got here escape to enter the command mode. Got a large handful of ways to navigate around in the file. We've got a number of things we can do when editing the file. We've got some things for saving and quitting. There is one thing that we haven't talked about the possibility of. Let me save this before I do anything destructive. :W. We've talked about saving or saving and quitting. But what if you've made a bunch of changes? I'm just going to put that this is stuff I don't want in the file. Maybe this was a lot bigger change than that, because this I could just delete the line and be fine. But I've made a bunch of changes, maybe all over the file, and I realized I didn't want to make all those changes. And I want to quit without saving, because that's going to be a whole lot easier than finding all my changes and going. If I go WQ without doing a save, VI actually will stop me. It will say, hey, don't do that. You haven't saved yet. And it tells me the answer. Add an exclamation point to that. So if I type :Q exclamation point, :Q bang is often how you'll hear it said, I can go without saving. And if I come here, do a capital G to go to the end of the file, you see I don't have my junk there at the end of the file. So let's document that. Quit without saving. And there we go. We've made our handy little quick reference. Now there's something I want to show as kind of one bonus command, and I'll talk through this. This isn't necessarily in our quick reference. You can decide if you want to add it to yours. This quick reference, this is the tools, and this will begin your journey to become a VI power user. there's enough there really to put you ahead of a large majority, if not the vast majority of VI users. I see a lot of people who don't know a lot of these fairly simple shortcuts to be able to speed up their editing. I want to show you one that's kind of cool. And actually I did it in a previous video and didn't talk about it. So we'll talk about it now. Think of this as bonus VI content. So we're going to take the Macbeth full. And again, this is just for demonstration purposes. This is not in your working files folder. I showed before we could find the word dagger and we could change dagger to kazoo. Let's talk about that command that I did and what I did. So we did a colon. We've seen colon before. Colon precedes a lot of the commands and opens this little command line at the bottom. And then I did a percent. Percent means every line. So for every line, I want VI to do something. What do I want VI to do on every line? I want it to substitute. The S is for substitute. And then the slash is just a delineator. So I want it to substitute dagger. And then I'd put my delineator again. What do I want it to substitute for dagger? I want it to substitute kazoo. That alone is enough. That command will do it. For every line, it will take the first occurrence of dagger and change it to kazoo. If there happens to be a line where dagger appears twice, it won't do that. So the last thing that I did was I added a G. G says global, if you will. It says do it for as many occurrences as there are on a line. Here's your bonus editing command. Colon %s slash. That's standard. Then what you want to replace, then a slash, then what you want to replace it with, then a slash, and then a G. And what that will do is it will replace every occurrence of the first thing with the second thing. So every occurrence of dagger gets replaced with kazoo. And then I can search for kazoo. And then we have Macbeth's famous soliloquy, is this a kazoo which I see before me, the handle toward my hand? Come, let me clutch thee. Have fun practicing with VI. Use that quick reference, maybe print it out, keep a copy handy with you. You will be well on your way to being a VI power user. Congratulations! You can now say that you're familiar with the Linux command line and mean it. Maybe when you started, this view right here looked a little bit intimidating. But now you can move around in the file system, look at the contents of files, manage permissions, edit files, add and remove users, and more, all from this simple window. Keep practicing. In the future, when you're looking at something to do on your Linux system and you're trying to figure out how to do something, look for the command line solution. Try those things. Read man pages. There's a lot of interesting things online that you can learn and do. And then, if you want to take it to the next level, consider learning shell scripting. Because the bash, we've talked about it as a shell, it's actually an entire programming language. And now as we wrap this up, there's one last command I'd like to show you. And it's the command cowsay. C-O-W-S-A-Y. And here's what it does. It gives you a cow who says something. Do check out the man page for cowsay, because it can do a lot more than just cows. Thank you for going through this course, and I wish you all the best in your future use of Linux.